Hey guys, Daniel here. Hope you guys are doing well. Hope you guys are studying hard. And big welcome to my predicted paper 2 for the Edexcel A-level maths exams in June. In June. Yeah, not too far away now. And a confession, this paper was meant to be out a long time ago, but I've just been so busy just with work and content and everything. So I finally got it out now, thankfully. And yeah, this is my paper 2. So I did paper 1 last month, and I'm sure a lot of you would have seen that. If you haven't, then I'll put the link in the description so you guys can check that out. And yeah, basically these two papers is just basically meant to give you a pretty much a full coverage of what could come up in your exams. And obviously, if you do both of these papers, then you should be in a good position. A couple of disclaimers. There are topics that aren't in this paper, which would most likely will be in your paper 2. So for example, I haven't got any integration by parts or substitution because I did those in my paper 1. But obviously in the actual paper 2, you're most likely going to get at least one of them. So yeah, that's just one thing to put out. Anything else? I haven't got any log linear modeling in here or exponential modeling as well. Yeah, I tried to just make two papers with as many topics as I could. So yeah, obviously make sure you revise everything. This paper is 111 marks. I think paper 1 was 107 and I gave you 2 hours 10. So you get 2 hours 15 for this one. So you just get a bit more extra time so you guys can just go through it in good time. And yeah, that's pretty much it. I don't think there's anything else. Do the paper first before watching this. If you're watching this and you haven't done the paper, then the paper will be pinned in the comments and it'll be in the description as well. So yeah, do the paper first before you watch this. And yeah, that is it. So yeah, let's get into it. Okay, so question 1 says f of x is equal to ax cubed minus 4 root x plus 3x squared plus 2 all over x, where x is greater than 0. Find the integral of f of x dx, given each term in its simplest form, and this is a 4 marker. All right, so firstly, integration. There's a lot going on here. What you want to do is just separate them and write them in terms of powers. So the ax cubed is absolutely fine. Now we know that we've got a root x there. That's x to the power of a half. And then this one we need to separate, don't we? So I'm going to separate it. So it's going to be 3x squared over x plus 2 over x, isn't it? And then now what I'm going to do is just simplify that. So I've got ax cubed minus 4x to the power of a half. And then that will just be plus 3x, wouldn't it? And then this one, I'm actually going to leave as a fraction because we can see quite clearly this is just going to be a natural logarithm, isn't it, when we integrate it? So I'll leave it like that. And then I'm going to put the integral sign. Dx, and then now we can go ahead and integrate. So first one is going to be 8 multiplied by x to the power of 4 divided by 4, add 1 to the power, and then divide by the new power. This one is going to be minus 4 times by x to the power of, add 1, 3 over 2, divide by that power, 3 over 2, and then plus, and then this is going to be 3, and then that's just going to be x squared over 2, isn't it? And then plus, and then as I said before, the integral of 1 over x is ln of x, right? So this is just going to be 2 ln of x. Now, you should put modulus signs, but they did tell us that x is greater than 0, so we don't need to. So I'll take them off, but you should do anyway. And I'm going to put plus c. Now it says give each term in its simplest form, so we need to simplify. So 8 divided by 4 is 2, so that's going to be 2x to the 4. Now what's going on here? I'm doing minus 4, and then I'm dividing by 3 over 2. That's the same as times by 2 over 3. And that is just going to be 8/3, isn't it? So that's going to be 8/3. So I'll put that there. 8/3. And then it will be x to the power of 3 over 2. And then that's just 3 over 2. And then that will be x squared plus 2 ln x plus c. And that's it. Finished. Okay, so question 2 says f of x is equal to x minus 5 times by x squared minus 4x plus k minus 30, where k is a constant. Given that x minus 3 is a factor of f of x, find the value of k for 3 marks. Okay, so this is just a factor theorem. Now, all you want to do is just set your factor equal to 0. If I do that, that means x will equal 3. And from the factor theorem, it means that f of 3 will equal 0, right? And then I'll just write the factor theorem here. Factor theorem. So essentially, all you need to do is just plug in x equals 3 into your function, set equal to 0, and then solve for k. So doing that will give me f of 3 will equal 3 take 5, and then it will be 3 squared take 4 lots of 3 plus k minus 30, and then we're going to set this equal to 0. 3 minus 5 is minus 2, so I'll put minus 2 on the outside. That's 9. That's 12 plus k minus 30 is equal to 0. That's minus 2, and then that is 9 minus 12 is minus 3 plus k. And then what I can do actually, that minus 3 I can add on to the right hand side, can't I? So it'll be 30. And then now I'm going to just divide by minus 2. So I'm going to have minus 3 plus k is going to equal minus 15. And then that would mean that k is going to equal minus 15 plus 3, which is minus 12. So therefore k is equal to minus 12. And that's it. Okay, so question 3 says a curve C has parametric equations. X is equal to t over t minus 2. Y is equal to 1 over t plus 3, where t is an element of the rules and t is greater than 2. Show that all points on C lie on the curve of Cartesian equation y equals ax minus 1 over bx, where a and b are constants to be found, for 3 marks. Now, firstly, we've got parametric equations. We've got x and y. They're both in terms of t. And they're asking us to show that these two equations can be written in a Cartesian form, where it's just y in terms of x. So we need to eliminate that parameter t and get it in terms of just y and x. And there's two types of classifications I like to do with these types of questions. The first one is when you've got to just use algebra, essentially, just rearrange to get it in the form. And the other ones, which are a bit harder, are the trigonometric expression ones, where you've got to use identities to get it into Cartesian form. So we're not doing the latter, we're doing the former, right? Because there's no trig involved here. So if I look at what we need to get to, it's y in terms of x, right? I can see y here is 1 over t plus 3. I've got x here. What I want to do is what you'd want to do is rearrange this formula, x in terms of t, to get into t in terms of x, and then plug it into y. So I'm going to start here. I've got x is equal to t over t minus 2. And then what I can do is I can just times up by the t minus 2. So I'm going to have x and then t minus 2 is equal to t. Expand. Xt minus 2x is going to equal t. Now remember, we want to make t the subject, don't we? Because we want t in terms of x to plug into y. So you're going to move everything with t's on one side and put anything else without a t on the other side. So I'm going to put that there, and I'm going to put that there. It's going to become xt minus t is going to equal 2x. And then now to isolate the t, is just making the subject. You're going to factor out the t. Take out a t, it's going to be x minus 1 is going to equal 2x. So therefore, t is going to equal 2x over x minus 1, isn't it? Now that I've got t in terms of x, I can plug that into my formula for y, which is y equals 1 over t plus 3. So I write this here again. Y equals 1 over t plus 3. And now I'm going to plug it in. So it's going to become y is equal to 1 over, and then 2x over x minus 1 plus 3. We're divided by a fraction, we can just flip it over. So it becomes y is equal to x minus 1 over 2x plus 3. Now let's look at the show that. What form do they want it in? They want a fraction, a complete fraction, no separate terms. So we just need to combine this, don't we? So it's just adding algebraic fractions together, isn't it? So put this there. And then now, if I put this over 1, the common denominator is going to be a 2x, isn't it? So put this there, put that there. That's a 2x, that's a 2x. There, this stays the same. Now, if I times the bottom by 2x, I times the top by 2x as well. 3 times 2x is 6x. So it's going to be 6x like that. And then now I can add these together. So it becomes x plus the 6 is going to be 7x minus 1 over 2x. So yeah, that is it. So I write y is equal to 7x minus 1 over 2x, and a is equal to 7 and b is equal to 2. And that's it. Finish. Okay, so question 4 says a sequence u1, u2, u3 is defined by un plus 1 is equal to b minus aun, and u1 is equal to 3, where a and b are constants. Part A says find in terms of a and b, u2 and u3 for 2 marks. Okay, so this is just recurrence relations, and I've got the questions summarized down here. So what I like to do, I'm sure you guys can do it very, very quickly, but I like to actually write out what they're asking me. So for example, u2 is going to equal b minus a u1, isn't it? Right? Just in terms of the definition, and I know that u1 is 3, so therefore that means that u2 is going to equal b minus a lots of 3, isn't it? So therefore we could say that u2 is equal to b minus 3a in terms of a and b. Now double our u3, again the definition, u3 is going to equal b minus a u2. Now we just figured out what A2 is. It's B minus 3A. So it's going to be U3 is going to equal B minus A and then U2, which is B minus 3A. Like that. And then now I can just tidy that up. It's going to be B minus AB and then plus 3A squared, isn't it? And then we can just say, just to make it a bit nice, u3 is going to equal 3a squared minus ab plus b. To be fair, any order's fine, but yeah, I'm going to write like that. So that's u3. So that's part A. Part B, what does part B say? It says, given that the sum of n equals 1 to 3 of un is equal to 153 and b is equal to a plus 9, show that a squared minus 5a minus 66 is equal to 0 for 3 marks. Okay, so that isn't too bad either. So just remember sigma notation. You need to understand the definition of sigma notation and what it's actually asking you to do. So let me just grab this and then put this underneath. So this out. Okay, so that bullet point there, right, with the sigma notation, that is just saying that you're just doing the first three terms. So u1 plus u2 plus u3, this is going to equal 153. Yeah. So what is u1, u2, u3? We've got that. So u1, I remember anyway, was 3. U2 was b minus 3a, wasn't it? Yes, it was. B minus 3a plus u3, which was 3a squared minus ab plus b. And this is equal to 153. That's what that first bullet point is telling us. Now, they want this expression here. So what I've got so far is expressions with a and b in it. I don't want a b because the show that is in terms of a. So that's where this second bullet point comes in. But before that, let me just tidy up a bit. So I'm going to put the 3a squared first. I've got a minus 3a. I've also got a minus ab. And then I've got two b's, don't I? I've got a 2b there. And then if I move this 153 over to the left, right, that's just going to be minus 150. And that's going to equal 0, isn't it? So with that being said, this is where I'm at. I need to show that I get this. That's where the second bullet point comes in. B is equal to a plus 9. I need to get rid of the expressions for b, isn't it? But I know b in terms of a, it's a plus 9. So I'm going to just sub that in now. So it's going to be 3a squared minus 3a minus a, and then b is a plus 9 from the second bullet point, plus 2 lots of a plus 9, minus 150 is equal to 0. So let's expand and simplify. 3a squared minus 3a, that's going to be a minus a squared. That's going to be a minus 9a. That's going to be a plus 2a. It's going to be plus 18. And then that's going to be minus 150, and that's going to equal 0. Tally it up a bit more. 3a squared and then a squared will be a 2a squared. I've got minus 3, minus 9, that's minus 12. Add the 2, that's a minus 10. So we minus 10a. And then I've got 18 minus 150. 150 take away 18 is 132, so it's going to be negative. So minus 132 is equal to 0. And then now, remember, we want a squared, isn't it? So if we just divide everything by 2, that will become an a squared. That will become a minus 5a, and then that will become minus 66 equals 0 as required. And that is part B. Now let's get part C. Part C says, hence find the larger possible value of u2. Okay, and that's 3 marks. Okay, so again, let's grab this. Whoops, let me grab it. Okay. So we're looking at u2, we're investigating u2. Well, what is u2? u2 was b minus 3, if I'm not mistaken. Yeah, right there. So let me write that down. u2 is b minus 3a, right? We want the larger possible value of it. So we need to figure out what a and b must be. Now, we can do that because firstly, we've got an equation in terms of a which we can solve. And we also knew what b was. B was equal to a plus 9, isn't it? Just 9 more than a. So let me write that down as well. So I'm going to write the two things that I need. B is equal to a plus 9. And I know that a squared minus, what was it? 5a minus 66 equals to 0. So I'm going to solve the quadratic to figure out what a must be and then plug it in there. So solving that, we can factorize, can't we? Equals 0. A there, a there. 2 factors of negative 66 should add to make minus 5. It's negative, so it's going to be minus 11. It's going to be a plus 6, isn't it? Perfect. And then that means that a is going to either equal 11 there, or a is going to equal minus 6 there, isn't it? So we've got two options for a, right? And then now that would mean we would have two options for b, right? So let's actually plug those in and see what we get. So if b is equal to a plus 9, then that one is going to be 11 plus 9, which is going to equal 20. Or b is going to equal minus 6 plus 9, which is going to equal 3. right? So we've got two options. We've got either A is equal to 11 and B is equal to 20, or we've got either A is equal to -6 and B is equal to 3, right? Now remember what the question is asking us for. Find the possible larger value. Find the larger possible value of U2. Now U2 is B take 3A. So let's write that out again. U2 is equal to B take 3A. Now, if I want the larger value, well, this is being taken away, right? And I've got A to be negative right there. So if I plug in a negative number there, those negatives are going to cancel. It's going to become a plus. So it's going to be this one. But if you want to be safe, just plug in both of them, B and A, see which one is larger, right? But it's going to be this one, just due to the fact that I'm taking it away. But you can always just check. So it's going to be U2 is going to equal, B is going to be 3 minus 3 lots of -6, like that. And then yeah, that's going to be 3 plus 18, which is 21. So U2 is 21. But again, as I said before, plug in that one. If I was to plug in A into there, right, then I'll be taking 33 away from 20, isn't it? Which would be -13. So yeah, it won't work. Oh, it won't, not that it won't work, but it won't be bigger than 21. So yeah, U2 is 21. And that's it. Finished. Okay, so question 5 says f of x is equal to log of base k of 12x minus 3x squared, where x is between 0 and 4 and k is greater than 1. Given that the equation f of x equals 2 has exactly two real solutions, determine the set of possible values for k. And this is a 5 marker. Now, if you look at this here, it looks a bit daunting in a sense where we've got logs and then we've got a base k. Normally you have a base given to you. But just break it down. Now, look at the language in the question, right? There's a couple of things that stick out to me. Now, the first part is the fact that I've seen exactly two real solutions, right? That phrase there. And the other phrase is just the next part of the sentence, essentially, isn't it? It's just determine the set of possible values for k. Now, this type of language comes up when you're dealing with the discriminant, isn't it, right? Two real solutions, k, right? That should come into your head. And also, if you look at the question, the argument of the log is a quadratic as well. So that is something to think about. Another thing is it says determine the set of possible values for k. Now, how do you determine the set of values of a variable? Well, that means it's just going to be, you're just going to be solving an inequality. So that's another thing to think of. So you need to solve an inequality essentially, and maybe form a quadratic equation or an expression or quadratic where you can find the discriminant. Now, let's have a go at it. Now, they've given us information. The equation f of x equals 2 has exactly two real solutions. So let's actually write out f of x equals 2. That is just going to be log of base k over 12x minus 3x squared is equal to 2, right? That would be my first line. Now, the fact that I've identified that this is potentially a discriminant question or quadratic question, I need to get rid of that log, right? Now, remember, just from your log laws and just from your algebra, if you ever want to get rid of a log, just look at what base it is here. You can use the equivalency formula as well, but I think this is always nicer, quicker. That base is a k, it's log of base k. To get rid of the log, you're going to raise both of these expressions with a base of whatever this is right here. So I'm going to raise both of them with a base of k. So put a k there and then put a k there. And then that will cancel with that. And you're done, right? So essentially the next line is going to be 12x minus 3x squared is equal to k squared. So I'm here. Now another thing as well, just a side note, right? Always make a note of the restrictions that's given to you. So any types of restrictions on x or any variables and so on and so forth. Always have that in the back of your mind when you do these types of questions, and you'll see why in a second. So we are here. We know that we are dealing with a quadratic, so let's move everything from left to right so it's in a nice form. So that would be 0 is equal to minus 3x will go to positive 3x squared, 12x will go to minus 12x, and plus k squared, like that. And then obviously I'll just move this to the other side so it just looks nicer. Perfect. All right, so we're here. Now this equation, right, is the same equation as f of x equals 2, right? This equation here is f of x equals 2. We've just used algebra to write it in a different form. Now, f of x equals 2 had exactly two real solutions. If this is the same equation, this also has exactly two real solutions, right? So it's the same equation. Now, this is a quadratic. If it has two real solutions, it must mean that the discriminant is greater than 0, right? So what I'm going to do is I'm going to form an expression. Actually, let me write this as well. Two solutions, just so it's super clear. Two solutions implies that the discriminant b squared minus 4ac is greater than 0. So let me find an expression for the discriminant and set it greater than 0 and then solve it, right? So A is going to equal 3, B is going to equal minus 12, and C is going to equal k squared. So that would mean, sorry, that looks like a cube, doesn't it? K squared. So that would mean B squared is going to be minus 12 squared. Take away 4 lots of A, which is 3, times by C, which is k squared. And then this must be greater than 0, isn't it? Okay. So now let's tidy. Minus 12 squared is positive 144. That's going to be minus 12k squared. And this has to be greater than 0. Let me add on the 12 squared, the 12k squared. It's going to be 144 is greater than 12k squared. I'm going to divide by positive 12, which will keep the inequality the same direction. So that's fine. Divide both sides by 12. We're going to have 12 is greater than k squared. And if 12 is greater than k squared, then that must mean that k squared is just less than 12. So I need to solve this quadratic inequality, right? How do I solve quadratic inequalities? Just sketch it. I'm going to do this. I'm going to do that. Hold on, let me make this a bit neater. Like that. This is the graph of k squared. So let's just say this was k-axis. Let's say this is y. This is the graph of y equals k squared. And I want it to be less than 12. So when is it equal to 12? It's going to be a horizontal line there. I need to figure out what these are. So if k squared is equal to 12, right? So k squared is equal to 12, then that must mean that k is going to equal plus or minus the square root of 12, which is the same as plus or minus the square root of 4 root 3, root 4 root 3, which is just 2 root 3, isn't it? So that there must mean that this is a 2 root 3, and this is a minus 2 root 3. So k ranges between minus 2 root 3 and 2 root 3. So let me write that there. So I'm going to say k is in between minus 2 root 3 and positive 2 root 3. Now, be very, very careful. Be very careful. Remember what I told you about looking at the restrictions? They told us that k is greater than 1, right? Now, they said determine the set of possible values for k. So before even looking at this, right, you could even look at the question and say, well, regardless of what k must be greater than 1. Now, if I go back to what we've got, right? We're saying that k ranges between minus 2 root 3 and 2 root 3, right? Minus 2 root 3 is negative, right? If k must be greater than 1, then that means that your final answer, let me write this, I'm going to write since k is greater than 1, right? Then your final answer is going to be k must range between 1 and 2 root 3. And that will give you the full 5 marks. Let me know if any of you guys got caught out with that in the comments. But yeah, that's it. Finished. Okay, so question 6 says figure 1 shows a sketch of part of the curve of equation y equals f of x, where f of x is equal to x minus 2 squared times e to the 3x, where x is an element of the reals. The curve has a maximum turning point at A and a minimum turning point at 2, 0. Part A says use calculus to find the exact coordinates of A for 5 marks. Okay, so we've got this graph here. Now, the first thing that sticks out to me is this phrase here, maximum turning point, and then the second one is minimum turning point. I always say this, whenever you see minimum, maximum, turning point, stationary point, these are all synonyms for dy dx is equal to 0. So all you need to do with this one is differentiate it, make it equal to 0. So what do we have here? We've got f of x, which is equal to x minus 2 all squared times e to the 3x. Now, this is a product of two completely different functions, isn't it? So we're going to use the product rule. So I'm going to say u is going to equal x minus 2 all squared. And then v is going to equal e to the 3x, isn't it? And we're going to do u dash. This is a chain rule problem. This power is 2. Bring it to the front. 2 bracket x minus 2. Power drops by 1. And then v dash, this is just going to be 3e to the 3x, isn't it? Now, product rule is uv dash times vu dash. So I'm going to times these two together and then add these two together when I times them. So it becomes, all right, f dash of x. This is going to equal, I'll put the e first. So 3e to the 3x and then x minus 2 all squared. And then plus these two, vu dash, which is going to be, I'm going to put 2e to the 3x. So 2e to the 3x and then x minus 2. And because it's to the power of 1, I can just remove the power. So yeah, this is dy dx or f dash of x in this case. And because we're looking for the exact coordinates of A, which is the maximum turning point, I need to set equal to 0, don't I? So essentially, I need to solve this equation. Let me just grab this and put this underneath just so, because I think my face is going to be cutting off. It's going to be cutting the text out soon. So let me put this here. Okay. So we need to solve this and make it equal. It's already equal to zero, so I need to solve it. What are we doing again? We've got two turning points. We have one of them already. We've got one at 2, 0. So when I solve this, I should expect to get x equals 2 as one of the solutions. And then obviously the other solution would be the x coordinate of a, isn't it? So doing that, we need to we need to solve this. We've got common factors all over the place. I could take out an e to the 3x. And then I could take out one factor of x minus 2, can't I? So I have x minus 2 there. And then in a bracket, what would I have? There's just 3 there. And then I would have one more x minus 2. And then this one will be just the 2, isn't it? And then this is equal to 0. So now we've factorized it. We're saying then, if this is equal to 0, then this must be equal to 0, or this, or that, right? So step by step, this is never 0. This is e to the x. There's an asymptote on the x-axis. That's never 0. So there's going to be no solutions there. X minus 2 is equal to 0 would mean that x is equal to 2, which makes sense because we saw that on the diagram that corresponds to this turning point here. And then the turning point at A, which is what we're looking for, must come from this one. So I need to solve 3 bracket x minus 2 plus 2 is equal to 0. Expand the bracket, 3x minus 6 plus 2 is equal to 0. 3x minus 4 is equal to 0. So that must mean that x is going to equal, add 4 divided by 3. So x is equal to 4/3. So geometrically, that x equals 4/3 corresponds to that point over there. Now the question asked us for the coordinates, the exact coordinates. So I need the y coordinate here as well, don't I? So I'm going to do that by plugging that into my original formula, which is that. So f of x was equal to x minus 2 all squared e to the 3x, wasn't it? So if I plug in f of 4/3, that will give me y. And that would be 4 over 3 minus 2 all squared times by e to the 3 and then 4 over 3. Okay, so what is that equal to? That is 4 over 3. Take away, that's 6 over 3, isn't it? And then that is, what's that? The 3's cancelled, don't it? So let's just e to the 4. And then 4 take away 6 is negative 2. So that's negative 2 or negative 2 over 3 all squared e to the 4. And then if I square that, that's going to be a positive 4 nines. So it'll be 4 nines e to the 4. So now we've got our y coordinate, don't we? So therefore, the coordinates of A, which is what we're looking for, is going to be x is, what was x again? 4/3, wasn't it? X was 4/3. 4/3, and y is 4 ninths e to the 4. And it's in terms of e because they asked us for the exact coordinates, didn't they? So that would be your answer for part A. Now, part B, it says, given that the equation f of x equals k, where k is a constant, has at least 2 distinct roots, find the set of values of k, given your answer in set notation for 2 marks. Okay, so what I'm going to do is I'm going to get this diagram. I'm going to get this graph and put it underneath, and I'll get the question as well. So let me just move my rubber out of the way. This here. Okay, so this is our graph here. And let's get the question again as well. And then we're good to go. All right. So f of x equals k, right? F of x is our function, it's equal to k. Well, that k here, right? Remember, if you think of this f of x, this is y, isn't it? Y equals k is just a horizontal line going through k. So what this is telling me is that our function uh, intersects a horizontal line at k, right? And that happens when it has 2 distinct roots. So what you want to do is say, okay, well, fine. Well, if I draw a horizontal line, let's say I draw a horizontal line there. How many roots do I have at the moment? Well, I have 1 here, I've got 2 there, and I've got 3. There are 3 roots at the moment, right? Now, we need to figure out the set of values of k for which you have at least 2. So we need to figure out the range of horizontal lines that will give us at least 2 points of intersection. So if I look at this here, well, the graph, as we can see quite clearly, is that it has an asymptote on the x-axis. So what is happening when you're on the x-axis? Well, there's only one point of intersection, isn't it? It's at that turning point right there, because the other part just shoots off and it just gets very close to the x-axis, but it doesn't actually get there. So when you're on the x-axis, there's one point of intersection. We need at least 2. The moment I go above the x-axis, right, any point above it, then I get at least 2, don't I? Right? And that continues, right? keeps going, continues until I get to just on top of this turning point of A, isn't it? Because right here, I still have 2 points of intersection, which is fine. But the moment I go anywhere above that, I only have 1 point of intersection. So what we can say from there is that the two critical values that we're looking for is going to be this one here, like that, and then this one here, isn't it? Just on top of the x-axis. I'll just do it like that so it's clear. Or to be honest, yeah, that's fine, like that. And then this value here, well, this is a horizontal line. This is going through our turning point at A, isn't it? And we've worked out that the y coordinate of that turning point was 4/9 e to the 4, right? So I'll write that there. This is 4/9. Let me work this out. This is 4/9 e to the 4, right here. Let me put this in the same color. Like that. And then obviously this line here is just the x-axis, which is y equals 0. And when you have 2 points of intersection, it's going to range between these two values, isn't it? Right? It's going to go through 4/9 e to the 4. That's going to be included, but the x-axis isn't because there's only 1 point of intersection there. So therefore your answer, remember, these are going to be values of k, by the way. Remember, in this case, we're saying that k is equal to 0. In this case, we're saying that k is equal to 4/9 e to the 4. Right? So therefore, the range of values is going to be between 0 and it's going to include 4/9 e to the 4. So that's your answer. However, it does say give your answer in set notation, and this part is just easy. Remember, when you're doing set notation, what they want to see is those curly brackets, right? So all you're going to do is say, okay, if I'm going to put curly brackets like this, curly brackets like that, and then you just want to define what type of constant k is. K can be anything, so we're going to say it's an element of the rows. And then you got to put a colon here such that, and then now you want to put your inequality in such that k ranges between 0 and 4/9 e to the 4 inclusive. And that's it. That is your answer. Okay, so question 7 says a metal post is repeatedly hit in order to drive it into the ground. Given that on the first hit, post is driven 100 millimeters into the ground. On the second hit, the post is driven an additional 98 millimeters into the ground. On the third hit, the post is driven an additional 96 millimeters into the ground. And the additional distances the post travels on each subsequent hit form an arithmetic sequence. Part A says we need to show that the post is driven an additional 62 millimeters into the ground with the 20th hit. Okay, so we know that it's arithmetic. So what I can do is get an arithmetic series going or sequence. So part A, I'll do it here. On the first hit, we know it's 100. On the second hit, we know it's 98, and on the third, it's 96, and so on and so forth, right? So this is going down by 2. So -2, -2. So that means we're looking at this here. It's arithmetic. Our first term is going to be 100. Our common difference D is going to be -2. And what we can do now is formulate a general nth term formula for this arithmetic sequence here. So I'm going to say that the nth term, I'll call it un, is going to equal a plus n minus 1d. This is the general formula. But in this case, plugging in a and d, it's going to be 100 plus n minus 1, and then d is -2. Okay, now they're asking us to show that the post is driven an additional 62 millimeters into the ground with the 20th hit. So I need to figure out what U20 is, isn't it? So I'm going to plug in U20. I'm going to plug in n equals 20 to give me 100 plus, and then if n is 20, 20 minus 1 is 19. And then times it by -2, that is 100. There's a minus there. 2 19s are 38, so it's 100 take away 38, which is indeed 62. So therefore it does drive 62 millimeters additionally, whatever. But yeah, that's part A, 62. Perfect. Part B, it says find the total distance that the post has driven into the ground after 20 hits. Okay, so formulating this, let me do this. Let me bring this here. Actually, I'll do it underneath. So part B, and what do we know? Well, we know that from here, the first hit was 100. Second hit was 98. Third hit was 96. Fourth hit was 94. And we've just figured out in part A. So let me write this here as well. This is first. This is second. This is third. This is fourth. And then we figured out in part A that on the 20th hit, which is going to be over here, that it travels 62 millimeters. So we need to add all of these together. isn't it? Because it asks us for the total distance. It's going to be a distance of the first hit, the second, third, fourth, all the way up into 20th. So we need to just sum to n terms. And now this is quite easy. We're dealing with an arithmetic series. So what do we know? We're summing to 20 terms. So n is 20 because we're summing to the 20th hit. We know that the first term was equal to is equal to 100, and the common difference is -2. So all we're going to use is the SN formula, which is SN is equal to n over 2, and then 2a plus n minus 1d, isn't it? So plugging in everything we know, we can figure out what that is. So I'll do it here. It's going to be S20. This is going to equal 20 over 2, and it's going to be 2 lots of a, which is 2 lots of a, which is 100, plus n, which is 20. 20 minus 1 is 19. So like that. And then d is -2, isn't it? So I'll put that there. And then what's that? 20 over 2 is 10. This is 200. We're taking away 38, which is 10 times 162, isn't it? And that is just equal to 1,620. So the total distance traveled from the first to the 20th hit, or after the 20th hit, is going to be 1,620 millimeters. And that's it. And that's part B. Let's look at part C. It says for part C, it says given that for each subsequent hit after the 20th hit, the additional distances the post travels form a geometric sequence with common ratio r. On the 22nd hit, the post is driven an additional 60 millimeters into the ground. Part C says find the value of r given your answer to 3 decimal places. Okay, so with this type of question here, just think of it in phases, right? In the first phase, we had the metal post being driven, and the distance it was driven into the ground for an arithmetic sequence or series, right? So what we can do is say, well, fine. Well, if I model it, I'm going to write part C here, right? Phase 1, that we know it was arithmetic, right? Arithmetic, and it went up to the 20 hits, and the 20th hit, right? Let me write 20th hit. 20th hit was equal to 62 millimeters, wasn't it? Now phase 2, right? It's going to start from the 21st hit. So let me write this here. I'm going to write A for arithmetic. This is arithmetic here. This is going to be the 20th hit, like that. And then after that, phase 2 is going to be geometric, isn't it? 21st, 22nd, and so on and so forth. Let me write G here. 22nd, and so on and so forth, right? Now, we know on this one, it was 62 millimeters. Now, to get the next term, right, if it's being formed geometrically now, then that means that this one is going to be, we're going to times by a common ratio of r, isn't it, to get this one, which is going to be 62r. And then to get the next one, it's going to be times by r again, isn't it? 62r squared. And then to get this one, it's going to be 62r cubed. So that is what, so let me put a line through here just so it's super clear. So from here, it's going to be phase 2. Yeah, 62r, 62r squared, 62r cubed, and so on and so forth. Now, they told us the distance after the 22nd hit, it was 62 millimeters, right? It's been driven an additional 60 millimeters. So with that information, I can use that to figure out what r is, because I have an expression for the 22nd hit. It's going to be 62r squared, isn't it? So therefore, I'm going to say that 62r squared, which represents the 22nd hit, which is right here. This one is going to represent the additional 60 millimeters it travels. So from there, I can actually say then that 62r squared has to equal 60. And then that way I can figure out what r is, isn't it? So if I divide by 62, I'm going to have 60 over 62, which is the same as 30 over 31, isn't it? 30 over 31. And that means that r is going to equal the square root of 30 over 31. And then putting that into my calculator, I'm going to get square root of 30 over 31. It's going to give me that number there. And then to 3 decimal places, which is what they asked us for, is going to be 0.984, isn't it? 0.984, and I'll write 3 dp. And that is it. And that's part C finished. Let's go to part D now. Okay, so part D says, after a total of n hits, the post will have been driven more than 3 meters into the ground. Part D says find, showing all steps in your working, the smallest possible value of n for 4 marks. Okay, now remember, this question is in two phases. We've got the first part of the question where the metal post has been driven and it forms an arithmetic sequence. And then the second part is when it's being driven and it's formed geometrically. So what you want to do is ask yourself, okay, well, we need a total amount of hits. Well, I'm going to write phase 1 and I'm going to write phase 2 again. Now, in phase 1, we know that there were a total of 20 hits. And in part B, we figured out that the total hits totaled 1,620 millimeters, isn't it? Right? So I'm going to say that the 20 hits here is going to be 1,620 millimeters, right? Now, in phase 2, there's a certain amount of hits that we're looking for, right? Now, we need to figure out what that is. And they've told us that after this amount of hits that we're looking for, let me call it N actually, because it is called N. Oh no, the total hits is called N, isn't it? Capital N. Let me just call this, I'll call this X hits, right? And then we know that in total, the metal post would have been driven more than 3 meters into the ground. Now, 3 meters, remember, this is just 1,000, that's 3,000 millimeters. 3,000 millimeters, right? So we need to figure out, well, if it's been driven more than 3,000 millimeters into the ground, and we initially know that in the first part it's been driven 1,620, well, what would the millimeters be that we're looking for, right? Well, all you're going to do is say, well, fine, well, let's call it Y actually. Let's call it Y. We know that in the two total phases, right? Phase 1 and phase 2. Phase 1, it travels 1,620. In phase 2, it travels Y. And we want this to be more than 3,000 millimeters, right? Because 3 meters is the same as 3,000. So we need to figure out what that is. So I'm going to say Y then must be greater than 3,000 take away 1,620, isn't it? And that must mean that the distance traveled is going to be, that is 1,380. Okay, so after phase 1, we want our metal post to travel more than 1,380 millimeters, and we need to figure out how many hits we would need for that to happen. Now, remember phase 2, it's formed geometrically. Remember, we said that the first hit, which is the 21st hit, right? The first hit, when it starts to become geometric, is the 21st hit. It's 62R, then 62R squared, then 62R cubed, and so on and so forth. So what we're actually saying here is that what we need, I write phase 2 again. I write P2 for short. We need 62R, that's the first hit, and then 62R squared, and then 62R cubed, blah, blah, blah. And we want this to exceed 1,380 millimeters, because that way it will exceed 3,000 millimeters in total. Now, what is this? Well, this is just going to be the total distance, right? And it's going to be the sum of our geometric sequence, isn't it? Now, remember, in part C, we know what R is. R was equal to the square root of 30 over 31, which is 0.94. Let me write approximately 0.984. But what I like to do is I'm actually going to use the actual answer. So it was the square root of R, or R was equal to the square root of 30 over 31, wasn't it? So I'm going to use that, and I'm just going to write equals 0.9837, blah, blah, blah. I'm going to use that moving forward. So I need to figure out what the sum of this is. Now, this is a geometric series. We're just going to use the SN formula, right? We're going to use that. So it's going to be SN is equal to, and it's going to be A 1 minus R to the N over 1 minus R. And we want this to be more than 1,380, isn't it? So with that being said, let me move this here actually. I'll put this here. And then I will put this here, and then I'll just say that this is the same as that, so it makes sense that these are following. Anyways, so yeah, what do we know? Well, remember, because we know what R is, we know we can figure out what A is, and then we can just plug it in. So I'm going to say then that A is going to equal 62 times by R, and I'm going to use this one here, 0.9837, blah, blah, blah. And then that way I can plug this into the formula. So that way, remember, we're looking for N, the total hits after the in phase 2. So I'm going to say Sn is going to equal A, which is that number there. That's A times by 1 minus R, which is 0.9837, blah, 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 to the power of N. And then this is going to be divided by 1 minus that same R. like that, and then this is going to be greater than 1380, and I just need to figure out what n is from there. So this isn't too bad. So what I'm going to do, just to tidy up a bit, I'm going to get this bracket here. I'm going to get this bracket by multiplying by this denominator here. I'm going to multiply it by 1380, and I'm going to divide by this one here, aren't I? And that will give me the bracket in yellow. So therefore I can say then that 1 minus 0.9837 to the power of n is going to be greater than 1380 multiplied by this denominator, 1 minus 0.9837 blah blah blah, and then it's going to be divided by that number there, 62 times by 0.9837 blah blah blah. Perfect. And then now I can just put this in my calculator, can't I? So getting my calculator up, I've got that number stored, so I'm just going to literally write, let me do it here. I'm going to write 1380 times by 1 minus answer over 62 times answer. And that gives me that number there. So I can say then that 1 minus 0.9837 blah, blah, blah to the power of n is going to be greater than that number, which is going to be 0.3679 blah, blah, blah. Perfect. And now I'm trying to figure out what n is. I'm going to move that there, and I'm going to move that there. So that would mean I'm going to have 1 minus 0.3679 dot dot dot. And this is going to be greater than 0.9837 blah 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 to the power of n. And now I can work out what that is. So with that being said, I'm going to do 1 minus answer. 1 minus answer to calculate what that is. That is 0.63207. 63207 blah blah blah. This has to be greater than that there. Now we're trying to figure out what n is. It's a power. So how do we get that power? We need to take logs, don't we? So I'm going to take log of both sides, aren't I? So if I'll take natural logs. I'll take ln. We'll take ln of both sides. I'm going to have 0.63207 blah blah blah, and this is going to be greater than the ln of 0.9837 blah blah blah. Now the reason why we're taking logs is because from our power rule, this power of n can drop to the front, isn't it? So it actually becomes the ln of 0.63207. And this has to be greater than that n will drop to the front, n ln of 0.9837 blah blah blah. And then that way we can divide it. Now the ln, if I divide that, you've got to be careful here. I mean, contextually, you'll figure it out anyway. But this number here, this argument is between 0 and 1. So that means that this is going to be negative, isn't it? You can plug it into calculator, you're going to get a negative number because 0.9837 is between 0 and 1. The ln of a number between 0 and 1 is negative, isn't it, from the graph? So when I divide it, the inequality is going to flip, isn't it? So it's going to be 0.9837, blah, blah, blah. And then this is going to be less than n. And that will give us the value of n. So put it into the calculator. What do I have here? I'm going to, now I've got that number stored, so I'm going to use that. So I'm going to put ln of answer at the top. Now this number here was just the common ratio, isn't it? Which I know exactly was the square root of 30 over 31. So I will use that now. Just always want to preserve all of your calculations as much as you can. And I get that there. So therefore I'm going to 27.981 is less than n, which will mean that n has to be greater than it, isn't it? So for context, what are we saying here? We're saying that for us to exceed this 1380 millimeters, right, we need the n to exceed 27.981. Now remember, n is the total number of hits, right? It has to be an integer. So if it's greater than that, that must mean we just round up, isn't it? So n has to equal 28. So now we've figured out how many hits are needed for us to exceed 1380, which will in turn which will in turn mean that we've exceeded 3000 millimeters, which is what they wanted. So again, let's look at the question one more time. The question asked us to showing all steps the smallest possible value of n. Capital N is the total number of hits, which is made up of the total hits in phase 1 plus the total hits in phase 2. Now we figured out that this total hits in phase 2 is 28, isn't it? So what I'm going to do is say then that the total hits now, I'm going to say total hits total hits, which is equal to capital N, is going to equal the number of hits in phase one, which was 20, plus the number of hits in phase two, which you've calculated to be 28, which is going to be 48 hits. And that's it. Finished. Okay, so question 8 says a lightweight drone is programmed to fly between three key delivery points relative to a fixed base O. The point A has position vector minus 2i plus 5j. The point B has position vector 4i plus qj, where q is a constant. The point C has position vector pi plus 8j, where p is a constant. All position vectors are measured in kilometers. Part A says, given that the straight line distance from point A to point B is exactly 10 kilometers, find the possible values of Q for 3 marks. Okay, so part A, they're asking us about the straight line distance between A and B, and it's 10 kilometers. So this is just another way of saying that the magnitude of the vector A to B is equal to 10. Right? So what I need to do is figure out the magnitude of A to B, equate it to 10, and then solve for Q. So where is A and where's B? Now remember, these are position vectors, aren't they? So this is just saying that this is O to A. That's O to A. That is O to B. And that is O to C, isn't it? So if I want the vector A to B, this is just B minus A, essentially, or A to O plus O to B, right? But I'll do B minus A. So what I'm going to do is I'm going to put them in column vectors, just because it's just easier for me to write, and then I'll put I and J. So I'm going to do the vector of B. The position vector of B is going to be 4q in column form, and I'm going to take away the vector of A, right? Which is going to be, if that's, oh no, that's fine actually. I'm not doing A to O, it's just going to be like that. So it's going to be a minus 2 and then 5, isn't it? Yeah, perfect. What I'm doing, just to clarify, I'm just doing the vector of B, take away the vector of A, or another way you could figure out or think of A to B is A to B is equal to A to O plus the vector of O to B, which is the exact same thing as what I've got here, just the other way around. So A to O is going to be, I'll just do it here so it's super clear. That would be 2 minus 5, and then plus the vector O to B, which is going to be 4, and then Q. You get the same thing, but yeah, just so it's super clear. Anyways, I'll do this one. So that one's going to be 4 minus minus 2 is a 6, and then Q minus 5 there. So this is the vector of A to B. Now, the magnitude of that is just going to be you're just going to do the Pythagoras of each of the components, isn't it? So it's going to be 6 squared plus q minus 5 all squared. And this is equal to 10, isn't it? Because they told us that. So what I need to do is just solve this, right? So if I solve that, then that will give me, if I square both sides, I'm going to have 6 squared plus q minus 5 all squared is going to equal 10 squared, like that. If I square both sides there, and then that way I could just say q minus 5 all squared is going to equal 10 squared, take away 6 squared, which is just 100 minus 36, isn't it? That's 64. So that's going to be like that, and that's going to equal 64. And that means that q take away 5 is going to equal the square root of 64 plus or minus. So it's going to be plus or minus 8. And that means that q is going to equal 5, if I move that minus 5 over, plus or minus 8. So therefore, q is either equal to 5 plus 8, or q is either equal to 5 minus 8. 5 plus 8 is 13. 5 take away 8 is minus 3. So therefore, q is either equal to 13 or q is either equal to minus 3. And that is part A. Now part B. It says the drone travels from point A to point C. Given that the angle between AC and the unit vector I is pi over 4 radians, part B says we need to show that P is equal to 1. All right, so let me grab that actually. So we don't need to keep going up and down. That there. And then put that there. And then let me get the information about the vectors as well, because I'm going to need that, aren't I? So let me just write about this part and then screenshot now. Okay, so the angle between AC and the unit vector I is pi over 4 radians. So what I would do is I would actually visualize what's going on here. So let me actually calculate what the vector A to C is. The vector A to C, right? Again, this is going to be equal to A to O plus the vector O to C. Now, if this is O to A, O to A is going to be a minus 2, 5. Then that means that A to O the other way, just put a negative on it, is going to be 2, negative 5. So therefore, A to C is going to equal 2, negative 5 plus O to C, which is going to be, in this case, it's going to be P and then 8, isn't it? Like that. Perfect. And then now that must mean that the vector A to C at the top is going to be 2 plus P. Minus 5 plus 8 is a 3. So therefore, we can say that A to C is actually equal to, I'll write in I and J form because it's in I and J form, is going to be 2 plus P I plus 3J. Now, the angle between AC and the unit vector I. The unit vector I is just the x-axis and it's a horizontal line, isn't it? Right? Going to the right. And it's pi over 4 radians. So I'm actually going to visualize that. So let's just say the vector A to C is like this. Let me draw a nice line. Let's say this is the vector A to C. This is the vector A to C. Now I know that the horizontal component of this vector, right, is 2 plus P. The vertical component is 3. Like that. And the angle that it makes with the horizontal, which is going to be this angle here, because it's the unit vector I it's making an angle with, is going to be pi over 4. So I'm going to put pi over 4 there. Now, we're trying to show that P equals 1, right? Now, think about it. You've got a right angle triangle, don't you? You can use trigonometry to get an expression or to get an equation in terms of P, right? This is going to be your opposite side. This is going to be your adjacent. Always remember you can do this with vectors. So with that being said, tan is what we're going to use, and if we're doing SOHCAHTOA, tan of that angle, pi over 4, is going to equal the opposite side, which is 3, over the adjacent side, which is 2 plus p. And let me write on top here, tan of theta is just equal to the opposite over adjacent is what we're using here. So that way we can use trigonometry, SOHCAHTOA, to write an equation in terms of p. And then now obviously we can just evaluate this, isn't it? If I times that up and then divide by that there, then that would mean that I would have 2 plus p is equal to 3 over tan pi over 4. Like that. And then let's work out what tan of pi over 4 is. Make sure you're calculating the radians. Tan of pi over 4 is going to be 1. Right? So we've got 2 plus p is equal to 3 over 1, which means that 2 plus p is equal to 3. What do I add onto 2 to make 3? It's obviously 1. So we've shown that p is equal to 1. And yeah, that's it. Finished. Okay, so question 9 says, Figure 4 shows the plan view of the design for a stage at a trade fair. The shape of the stage ABCDEFA consists of a rectangle ACDF joined to two congruent sectors of circles. ABC is a sector of circle center A and FDE is a sector of a circle center F. Given that AC is 2r meters, CD is r meters, and angle DFE is theta radians, and the area of the stage is 30 meters squared, show that the perimeter P meters of the stage is given by P is equal to 4R plus 30 over R for 5 marks. Now, this is these types of questions whereby you have to basically use the information given to form two different equations, plug something into the other to get the expression that you want. So firstly, what I would do is find an expression for the perimeter. Now, when I look at this diagram, well, what do we know? We know that ABC is a circle, is a sector of a circle center A, right? Now, if this is the center A right here, then A to B has to be the radius, isn't it? And I know that A to C is also the radius. So that means that this is 2R. And since it's congruent to that triangle, that means this is also 2R. And so is that. Okay. What else do we know? We know that this is the angle theta 2 because it's congruent, it's the same thing. And we need to figure out what the perimeter is. Now, we've got this arc length that we need to calculate. Now, remember your formulas. The arc length is just equal to r theta. So the radius times by theta. In this case, the radius is 2r. So this is going to be 2r theta. And then this is also going to be 2r theta. And this is a rectangle here, isn't it? So that's going to be r. So we want the perimeter. So let's get an expression for the perimeter. I've labeled every side that we need, haven't I? So I'm going to say that for part A, the perimeter P is going to equal, I'm going to do it from here and then go around anti-clockwise. So it's going to be 2R plus 2R theta plus R plus another 2R theta plus a 2R. and then plus r, isn't it? Like that. That is going to be our expression for the perimeter. So tidying that up, what do I have? I've got how many r's? I've got 2r, 3r. I've got 6r's altogether. So I've got 6r there, and then I've got 4r thetas. So with these questions, remember, they're asking you for the perimeter. This is your answer. This is the perimeter. However, the form that they have it in, they don't have theta in their expression. So we need to figure out how we can substitute theta, right? We need to get theta in terms as well, essentially. And this is where that second piece of information comes in, where they told us that the area of the stage is 30 meters squared. So if I get this diagram here, what I'm going to do actually, you know what I'm going to do? Let me rub this out and then I'm going to annotate it again. So let me grab this just so it's neat. And then I'll put this here. Okay, so I need to figure out what the area of this is here. Now let's get an expression for the area, right? Because we know what it is, it's 30, but let's get an expression for it. What would that be? Well, remember your formulas for sectors. The area of a sector is half r squared theta. Now remember the radius is 2r. So the area of this sector is going to be a half, and then it's going to be the radius squared, which in this case is 2r. So 2r squared and then theta. This is going to be the same because they're congruent. Let me just put the theta angle there as well. And it's going to be a half and then 2r all squared and then theta. And this is a rectangle. It's r by 2r. This is going to be 2r squared. So therefore, we can say that the area, and is it the area, where is it? Area of the stage. I'm going to say area of the stage. This is just going to equal, no, I can zoom in a bit to be honest. So this is going to be, area of this stage here is literally just going to be equal to 1/2 2r all squared theta plus 2r squared plus a half and then 2r all squared theta. Now I've got two of the same thing. I've got two lots of a half 2r squared theta. So these two will simplify to be two lots of that same expression algebraically, wouldn't it? So I get that there. Squared there and then theta and then plus 2r squared. And tidying that up, the 2.5 will cancel. It's going to be 2r all squared theta, which is just going to be 4r squared theta, isn't it? And then plus 2r squared. Now remember, this is the area of the stage, which they did tell us is equal to 30 meters squared. So therefore, I can just equal this. I can equate this to 30. So I get this here. Now, remember what we're trying to do? We know what the perimeter is. The perimeter is 6r plus 4r theta. We're trying to show that the perimeter is equal to that. So we need to find an expression or an equation for theta in terms of how to plug back into this equation here. So I'm going to do that here. And it's the same thing with these types of questions. It's always the same type of thing. Two different equations, plug one into the other, and you're done. So let me copy this and put this there. So let me first rearrange to get theta from the second equation. So that would be 4r squared theta is going to equal 30 take 2r squared. I'm going to divide by 4r squared, aren't I, to give me 30. Theta is equal to 30 take 2r all squared over 4r squared. And then what I can do is I'm going to just divide everything by 2 because I can, can't I? So it'd be 15 minus r squared over 2r squared. And that is going to be my answer so far. So that's theta. Now I need to put theta back in here. Now remember, it's a show that question. Always have what you need to show in mind, just so you can see where you're going and if you're on the right track. So I'm going to put that there. Okay. So, whoops, it's the wrong one. Let me get it again. Or you know what, I'll just write it. P equals 4r plus 30 over r. That's what we need to show. So I'll just write it instead. P equals 4r plus 30 over r. That's what we need to show. So I'm going to plug in theta into my equation for the perimeter, which was here. Plugging that in. That will give me, doing that. That will give me P is equal to 6r plus 4r, and then theta I now know is 15 minus r squared over 2r squared. So tidying that up, what can we do? Well, P is going to equal 6r. Now without expanding it, I can actually just simplify, can't I? Because I've got a 4 there and I've got a 2, so I can cancel those. 2 goes into 2 once, 2 goes into 4 twice. There's a 2 there. And then I've also got this r, isn't it? Which I could cancel with one of them at the bottom. This r can cancel with one of those r's here. So that will just be 1. And then that will change to a 1, isn't it? So therefore, it's just going to be 2. And then in the bracket, it will be 15 minus r squared on the top. And then on the bottom, it's just going to literally be 1 times r, isn't it? Which is just going to be r. So we get that there, and then now we can just expand and simplify. So I'm going to have P is equal to 6R plus, and then if I expand that, that 2 will just times the numerator. It's going to be 30 minus 2R squared over R. And then remember to show that, we want to show that we get 4R plus 30 over R. So what do we need to do here? Well, we can separate this fraction on the right. So it becomes P is equal to 6R plus 30 over R, which is what we need. And then minus 2R squared over R. And then that becomes 6R plus 30 over R. And then we can cancel one of the R's, isn't it? Like that. So therefore, it's just going to become minus 2R, isn't it? And then obviously now, 6R take away 2R is a 4R. So it's P is equal to 4R plus 30 over R as required. And that's it. And that's part A. So yeah, that's part A. Let's go to part B. What does part B say? Part B says use calculus to find the minimum value for P, given your answer in the form A root B, where A and B are integers to be found. So they're asking us for a minimum value of P. So remember, P is a variable which depends on R, right? If I want to minimize P, then I've got to use calculus, right? And they've actually said it in the question. So what do we do? Remember that word minimum? That means you're going to differentiate, right? It's going to be a stationary point essentially. So you're going to differentiate your expression for P, find out what R is, by making it equal to 0, and then yeah, just using algebra. So let's do that. So firstly, for part B, I'm going to rewrite the 30 over R to be 30R to the minus 1. The P by the R now, by differentiating, is going to be, that 4R will go to a 4. And then the minus 1 will drop to the front, so it becomes minus 30. R, take 1 away, minus 2. And then this is equal to 0 because it's the minimum value we're looking for. So the gradient is 0 at that point. So I'm going to solve this. Now, whenever I see these types of questions, right, I like to rewrite this as a fraction just so it's easier to solve. And you'll see why. So it's going to be 4 minus 30 over R squared is equal to 0. And then now, for me, I'm just going to times up by R squared. Right, so I'm going to have 4R squared minus 30 is equal to 0. That means that 4R squared is equal to 30. And that means that R squared is equal to 30 over 4, isn't it? Which is just the same as 15 over 2. So therefore, R is equal to root 15 over 2, isn't it? Not plus or minus because we're dealing with a length here. So I'm just going to say the square root of 15 over 2. So that is the radius. Now, remember the question asks us to find the minimum value for P, not just the value of R that minimizes it. So what I need to do now is plug in R back into my formula for P, right? Which is that one there. So let me grab that. Well, I know actually P equals 4R plus 30 over R. P is equal to 4R plus 30 over R. So if I plug that in there, then what will we get? So you know what? Let's just do a bit of calculator work because yeah, you can. So 15 over 2, that is root 30 over 2, isn't it? Fantastic. So that means we'll have P is equal to 4 times root 30 over 2 plus, and then 30 over root 30 over 2. And let me just double check. Yeah, that's all good. So tidying that up, that's going to be P is equal to 4 divided by 2 is 2. This is 2 root 30 plus, and then this is going to be 30 times by, flip that over, 2 over root 30. And then now, what we can do is say we've got 2 root 30 there plus, and then we can actually rationalize this, can't we? We can just do that and that. So that way it just becomes, it's just going to become 30 times 2 is 60. It'll be 60 root 30 over 30. And then that is 60 over 30. That's just 2, isn't it? Right? Perfect. So therefore, it's literally just P is equal to 2 root 30 plus 2 root 30, which is equal to 4 root 30. And the question did ask us to give it in the form of A root B, didn't it? Yeah. So I'm just going to say A is going to equal 4 and B is going to equal 30. Perfect. That's part B. Now part C, where's part C? Need to go all the way up here. It says justify that the value of P found in part B is the minimum. Okay, so when they ask you to justify a minimum or maximum, this is where your second derivative comes in. So you find out your stationary point, right? By differentiating once, set n equal to 0. Now you want to just check whether that's a minimum or maximum. So all you're going to do here, let me just write this here. So if you're looking for a minimum, right? So for a minimum, all right, for a minimum, right? Then the value of your station, the value of x, right, that you or r, whatever variable it is, whatever you value you get for your stationary point, right? If you plug that into your second derivative, then it should be greater than 0, isn't it? So for a minimum, you need your second derivative, right? In this case, I'm gonna just I'll use it generally like that. This has to be greater than 0 for a minimum, right? This is just in a general sense. Now, in our case, we're dealing with P in terms of R, isn't it? So I need to do D squared P over dr squared, right? And I need to plug in my value of R that I got, which we are supposedly saying minimizes it. I plug that in and check that I get I get greater than 0. So what was dp by the R? It was equal to this expression here, wasn't it? So it was this one, isn't it? Let me copy this without it being equal to 0. So this one is the PDR. So differentiating that again is going to be d squared p over dr squared. That is going to equal, that 4 would go, wouldn't it? And then -2 will drop to the front to be a positive 60, and it'll be r to the -3. Now that's just 60 over r cubed. Now r is a radius, it's positive, so any number I plug into into this formula is going to be positive anyway, but just put your actual value of r in, which was equal to this thing here, root 15 over 2. Yeah, so if I plug in r equals root 15 over 2, I'm going to get 60 over, and then root 15 over 2 all cubed. And I put this into my calculator and see what I get. So it's going to be 60 over, and then I have it stored, don't I? Like that, and then squared. That gives me 21.9 approximately, right? Which is greater than 0. And you can just write hence minimum. Hence min. Whoops. It's kind of hard to write with these things. Hence minimum. And that's it. Let me put approximately. Right? But the main thing is that it's greater than 0. So therefore it proves that it's a minimum value. So yeah, that's it. Finished. Okay, so question 10 says, the graph shown in figure 2 has equation y equals a minus the modulus of 2x minus b, where a and b are positive constants and a is greater than b. Part A says, find, given your answer in terms of a and b, the coordinates of the maximum point of the graph, the coordinates of the point of intersection of the graph of the y-axis, the coordinates of the point of intersection of the graph with the x-axis, and this is 5 marks. So I've got this summarized down here, just so it's just easier to look at. So firstly, part I, the coordinates of the maximum turning point of the graph. So whenever you're dealing with modulus types of questions, right, and you're looking for the maximum, right, or minimum, depending on which way it is, it's just the vertex, isn't it? And you always get that by just literally setting the thing inside the modulus equal to 0, right? It kind of works like a quadratic, right? Like for example, let's just say I have, I don't know, y is equal to, I don't know, x minus 8 all squared plus 7. From our rules, we know that the turning point is just going to be 8, 7, right? But imagine I didn't know that. Let's just make this equal to 0, right? X minus 8 is equal to 0. X is going to equal 8, right? And then if I plug 8 into there, then that will disappear and it'll give me y equals 7. So it literally works the same way, right? And obviously, if I was to sketch this graph, it will look like this, isn't it? 8, let's say 8 is there. Let's say 7 is there. And it'll just look like that, right? And the coordinate will be 8, 7. So just a rule of thumb, if you ever see these types of questions and you want to look for the vertex or the turning point of these types of modulus functions, just set the thing inside equal to 0. So with that being said, let me get rid of this and then actually do it. So with that being said, I'm going to make 2x minus b equal to 0, right? So 2x minus b is going to equal 0. That means 2x is going to equal b. That means that x is just going to equal b over 2. Now I know what x is at that point. I plug x back into my original formula. Now that's just going to give me a, isn't it? Because this is going to be 0. But just for completeness, I'll do it anyway. I'm going to say y is going to equal a minus the modulus of 2 lots of x, which is b over 2 at that point, minus b. And then obviously you can see that the 2's are going to cancel. This is b take away b, isn't it? So it's y is equal to a minus the modulus of 0, which is just 0. So y is equal to a. So therefore your maximum point is going to be x is b over 2, and your y coordinate is going to be a. So that's I, right? Now, double I says the coordinates of the point of intersection of the graph of the y-axis. Now, when you're on the y-axis, x is equal to 0, isn't it? So what I'm going to do is make x equal to 0 there, isn't it? So let me just get double I. So double I, I'm going to say x is 0. So I plug in x equals 0 into there. I'm going to say y is going to equal a minus the modulus of 2 lots of 0 minus b, isn't it? And then now I can say, well, I've got y is equal to a minus the modulus of, that's just going to be 0. This is going to be minus b. The modulus of minus b is just going to be b, isn't it? So y is going to equal a minus b. So therefore, the coordinates of the point of intersection with the y-axis is going to be x equals 0. It's going to be a minus b. Perfect. Now, that triple I should say. Now, this is just a point of intersection with the x-axis. And again, the x-axis is when y is 0. So we're going to set y equal to 0 and then solve it. But what I'm going to do, let me just get the actual graph for context as well, just so we can see what we're doing here. And yeah, we should be good. Let me just put this here, grab that, and then I'll just put that there. Okay. So triple I, we want the intersections with the x-axis. So that's when y is equal to 0. So let me get the graph as well, or the equation of the function I'll get as well. And with the x-axis, I want y equal to 0, don't I? So what I'm going to do is I'm going to literally just set y equal to 0 and solve. Yeah. So it's going to be 0 is going to equal a minus the modulus of 2x minus b. And then I need to solve this, don't I, for x, isn't it? So I'm going to move this whole thing over to the left, aren't I? Because it's negative. So it becomes the modulus of 2x minus b on that side is going to equal a. Now, whenever you're solving these types of questions, remember the modulus just literally means plus or minus. So I'm going to have two equations here. The first equation is going to be when I have the positive of this thing inside. So the positive of 2x minus b is equal to a. And then the second one is going to be when I have the negative of that same thing is equal to a. So I'm going to solve both of these. This one, the plus I can get rid of, so it'd be 2x minus b is equal to a. I'm going to say 2x is going to equal a plus b. And then x is going to equal a plus b over 2. Perfect. So one coordinate, right, is going to be when x is equal to a plus b over 2. And then the y coordinate is going to be at 0, isn't it? So that's one of them. And then this one here, the negative version, you can divide by -1, or yeah, I'll times both sides by -1 now. So 2x minus b is going to equal minus a, right? Or you could have expanded that -1, it doesn't matter. And I'll just do this because it's just a bit quicker. So that would mean that 2x is going to equal, if minus b is on this side, that's just going to be positive. I'm just going to write b minus a. And then that means that x is equal to b minus a over 2. So therefore, the other coordinate is going to be b minus a over 2, and then 0, like that. Now, for context, where does everything go? Well, remember we figured out where the vertex was. The vertex was this point here, and that was b over 2 and then a. Right, so that is b over 2 there. That's a. So a is positive. That's good. The y-intercept was over there. And what did we say the y-intercept was again? It was 0a minus b. Yeah. So this is going to be a minus b over there. Now, which way do these go? Now, remember there was a bit of restrictions on a and b, right? They're both positive. They told us actually. That's good. And a is greater than b. Right? So if a is greater than b, then, well, a plus b over 2 is positive. There's no way that can be negative. So that's going to be this one, like that. And I'll write, let me do it here. All right, a plus b over 2. That's that point there. And then this point over here, b minus a. If a is greater than b, then b minus a is negative, right? So that is going to be over there. So b minus a over 2. And yeah, that would be it. We've labeled everything. We've got our vertex, we've got our y-intercept, we've got our x-intercepts. And yeah, that's it. Finished. Okay, so part B says, on the next page, there is a copy of figure 2 called diagram 1. On diagram 1, sketch the graph with equation y is equal to the modulus of x minus 1 for 2 marks. So I've already got diagram 1 here for us. Now, we need to sketch this graph. It doesn't say anything about the intercept, so I guess we don't need to draw it, but I'll do them anyway. The modulus of x, that is just the v, like this, isn't it? Right? And then if I minus 1, it's just going to literally just drop down by 1. So what I'm going to do is just draw that on the graph, right? So I'm going to draw a nice line like this, do like that. And then also as well, by the way, the gradient of this line here, the one that we have already, is 2, isn't it? Right? Now, because it's x, that's going to be a gradient of 1. So it's going to be a little bit flatter. So always just be aware of that as well. Yeah, so I'm gonna do that there. So it's gonna look something like that. Is that a little bit flatter? I mean, it really doesn't matter, but yeah, maybe like that. It's a little bit flatter. And then I'll do it on the other side as well. So it's gonna look something like that, isn't it? So got that there. And now this is the modulus of x, isn't it? This is y is equal to the modulus of x. I need to shift it down by 1 unit. So I'm going to grab this and then literally just shift it down. So it's probably going to be maybe like that, right? Going to look like that. And this right here is going to be y is equal to the modulus of x minus 1. Perfect. And obviously, the intercepts are going to be at 1, minus 1, and then minus 1 down here, isn't it? Okay. Now, that's part A. That's part B. Part C says, given that the graphs of y equals the modulus of x minus 1 and y equals a minus the modulus of 2x minus b intersect at x equals minus 3 and x equals 5, part C says we need to find the value of a and the value of b for 4 marks. Now, with this type of question, I liken it to a question in paper 2 of the June 2023 series, question 12, right? And the reason why is because you need to really understand the modulus functions and also understand the different combinations. So have a check out that question and see how you get on with it as well, because it's pretty much the same. Now, the reason why I say that is this. Well, we know that it intersects at 2 points, x equals minus 3 and x equals 5. So let's plug that in. So let's say minus 3 is going to be that one, obviously, like that. That's going to be minus 3. Let me rub out these actually. You know what? I'm just going to rub out these points here for now. You don't need them. So minus 3 is going to be there. That's going to be the 1 point there. And then this point is going to be at 5, isn't it? So I need to figure out what a and b is. Now remember what the actual definition of a modulus graph is. It's actually just a piecewise function. Remember, the modulus of x, right, which looks like this, is literally just made up of 2 lines. One of them is y equals x. That one. The other one is y equals minus x, right? And you just bring them together at the origin. So it's actually just 2 lines joined together. So when I want to solve for a and b, and I'm looking for specific points of intersection, I need to ask myself, what specific part of the lines am I looking at, right? So for example, if I look at the right-hand side, the point of intersection where x is 5, right? Well, I have this line going down like that, and I've got this one going up. So what are the actual equations of each of these lines? Well, the green one, right, is the modulus of x minus 1. Well, the graph is going up. So this graph right here is actually y is equal to x minus 1, isn't it? Because the gradient is positive, it's 1, right? This one, the graph is going down, so the gradient is negative. Now remember, this is our original function for it. If the graph is going down, the gradient is negative, then remember y is equal to a minus. Now remember, this modulus means plus or minus, isn't it? Now, which one do I want? Well, the graph is going down. I want it to be negative. Since there's already a negative on the outside, I'm going to choose the positive version, because a negative times a positive will make a negative, and that will give me the negative gradient. So this graph here, if I just tally this up a bit more, it's going to be y is equal to a, and then that will just be minus 2x minus b. And then if I expand that out, that's going to be y is equal to a minus 2x plus b. isn't it? So this graph here is actually that one I write here. Y is equal to a minus 2x plus b. So the point of intersection with this one, where x is equal to 5, is going to be when I equate these two equations, isn't it? So I'm going to say for one of them, I'm going to write when x is equal to 5, it's going to be x minus 1 is equal to a and then minus 2x plus b. And I need to solve that, right? Which we'll do in a second. Now, you're going to do the same thing for the other side, right? There's another point of intersection. Again, ask yourself, which part of the graph am I looking at? Well, this one here, again, very, very easy. This graph is going down now. This side of the graph is going down. That means that it's going to be the negative part, right? So it's going to be, remember, this is the modulus of x minus 1. We're going to choose this one to be y equals minus x minus 1, isn't it? And then again, for the upside down V, this one over here. Okay, well, this graph is going up, isn't it? Right? So again, because it's going up, the gradient is positive. So which one am I going to choose? Well, we chose the negative one here. So we're going to choose it to be y is equal to a, and it's going to be negative, isn't it? So it's be minus a minus. I remember it's plus or minus, but we're going to choose it to be the minus one because of the fact that when we have two minuses, the minuses will cancel and it'll be positive. Yeah. So remember what we did here. This one was the positive version because we wanted overall the gradient to be negative. This one is the negative version because we want overall the two negatives will make a positive. So that way, if I just tidy that up a little bit more, I'll just do it underneath here just so it's super clear. Let me put this down a little bit like that. And I'm going to say y is equal to, and then it's going to be the two negatives will cancel. It's going to be a plus and then 2x minus b, like that. So the point of intersection when x is equal to 3, I'm actually solving which two equations? X equals minus 3, sorry. It's going to be y equals minus x minus 1, and I'm going to equate it to that one there, isn't it? Right? So it's going to be minus x minus 1 is equal to, and then it's going to be a plus, and then bracket 2x minus b. I can just write as 2x minus b, like that. So now I'm solving these two equations. Let me write that so it looks like more like an equal sign. Okay, now remember the questions ask us to find the value of a and the value of b. So we know which two equations we're solving. Let's plug in our values of x to just eliminate x and get in terms of a and b, and then it's just a simultaneous equation after that. So the first one here, I'll do it here. That's going to be 5 take away 1 is going to equal a minus 2 lots of 5 plus b. And then that would mean that if I tidy that up, that's going to be 4 is equal to a minus 10 plus b. And then if I move the minus 10 to the right, I'm going to have 14 is equal to a plus b, which in other words means that a plus b is equal to 14. And then the next one, x equals minus 3, I'll do that there. That's going to be minus and then minus 3 minus 1 is going to equal a plus 2 lots of minus 3 minus b, isn't it? And then tidying that up, two negatives make a positive. It's going to be 3 take away 1 is going to equal a, and then that's going to be a minus 6 minus b. And then in that case, that's going to be 2 is equal to a minus 6 minus b. And then that can go there. And then that would mean that I would have 8 is equal to a minus b, which in other words means that a minus b is equal to 8. So we get these two simultaneous equations. So I'm going to write them out again. A plus b is equal to 14. A minus b is equal to 8. Let me add them two together. So add. That's going to be 2a. The b's are going to cancel. 14 plus 8 is 22. So 2a is going to equal 22. And then a is going to equal 11. So now I know what a is. I can just plug it in to figure out what b is. So I'm going to plug that in there. I'm going to have 11 take away b is going to equal 8, right? And that would mean that if I move that there and I move that there, then that means that 11 minus 8 is equal to b. So therefore b is equal to 3. And therefore your answer overall is a is going to equal 11 and b is going to equal 3. And that's it. Okay, so question 11 says, figure 4 shows a sketch of the closed curve with equation x plus y all cubed plus 10y squared is equal to 108x. Part A says, show that dy dx is equal to 108 minus 3 times x plus y all squared divided by 20y plus 3 lots of x plus y all squared for 5 marks. Okay, this is just standard implicit differentiation, isn't it? We have a function or a curve and it's neither expressed explicitly in terms of x or y, it's in both, so we know it's implicit. So what I'm going to do is let me just grab the equation, And then I'll just get to show that as well. So I'll get these two, just so I don't need to keep going up and down. Okay, so we got to differentiate that then. We need to show that we get that. So firstly, if I differentiate this term over there, then I'm going to apply the chain rule. Now, this is a composite function. So remember, we're differentiating with respect to x, by the way, but it's in terms of x and y inside. So it's going to be x plus y, right? Now, remember that 3 is going to drop to the front, and then that power of 3 will drop by 1, so it'll be a 2 there. And then remember with the chain rule, you're going to multiply by the inside derivative. Now, when I differentiate this here, I differentiate term by term. When I differentiate x, I get 1, right? And then when I differentiate y, I'm differentiating y with respect to y, and then I'm multiplied by dy dx, don't I? So it's going to be plus, and then it's just going to be 1 dy dx, or just dy dx, isn't it? Now we've got more than one term here, so I have to put a bracket around it. And that is that term done. Now the next term, again, we'll differentiate with respect to x. So we'll differentiate with respect to y first. It's going to be just 20y, and then we multiply by dy dx. And then this is going to equal, differentiate 108x will just be 108, isn't it? So I get that there. Now I need to show that I get that. So I need to figure out what dy dx is, or make dy dx the subject. So what I'm going to do, instead of expanding all of this, you don't need to do this. Just treat this as one term. I'm going to treat this as one term, and I'm going to expand this bracket here. So when I do that and that, then that will just give me 3x plus y all squared, isn't it? 3x plus y all squared times 1 is just 3x plus y all squared. And then plus, and then I'm going to do this one and that one, isn't it? And then you just put them next to each other, right? So it's going to be 3x plus y all squared, and then dy dx, right? And they want you to do that because you can see in the show that they haven't expanded. Anyways, that's fine. And then continuing, 20y dy dx is equal to 108. Now I need to rearrange to get that form. So what I'm gonna do is I'm gonna move this to the right, aren't I? I'm gonna move that to the right. And then what I'm gonna do, just because I can see that it's in that order, I'm just gonna put the 20y first. It doesn't matter, but I'll just do it like that. So I'm gonna put the 20y first, 20y dy dx plus 3x plus y squared dy dx, and that will equal 108 minus 3x plus y all squared. And then now, what can I do from here? I can factorize out, isn't it? I can factor out a dy dx from both of these terms here. So it'll be dy over dx, and then in a bracket, it will be just a 20y plus that term there, 3 and then x plus y all squared. And then this will equal 108 minus 3 lots of x plus y all squared, like that. And then now from here, what we can do is divide by that bracket, and then we're going to get dy dx. dy over dx is going to equal 108 minus 3 and then x plus y all squared over 20y plus 3 and then x plus y all squared. And that's exactly what they wanted us to show, isn't it? Yeah, perfect. And that's it. And that's part A finished. Okay, so part B says the curve is used to model the shape of a cycle track with both x and y measured in kilometers. The points P and Q represent points that are furthest north and furthest south of the origin orb, as shown in figure 4. Using the result given in part A, find how far the point Q is south of O. Give your answer to the nearest 100 meters for 4 marks. Okay, so let's look at our diagram here. Now, the points P and Q, they've told us is furthest north and furthest south. Now, what does that actually mean in context? Furthest north, that's going to be a maximum. Furthest south is going to be a minimum. So again, you should be thinking about calculus, stationary points. What do we know about those points when you're at a max and a minimum? Stationary point, dy dx is equal to 0. And another thing as well is if you look at the lines here, these dashed lines, these are horizontal, right? These are tangents, right? Now remember, again, the gradient of a function is defined as the gradient of the tangent at that point, right? So with that being said, if these lines are horizontal, then again, the gradient must be 0. And if you think of it as well, that must mean that there's going to be no change in y, right? Because it's just going across. There's no vertical change. So with that being said, you can actually say then that if you think of dy dx as a literal fraction, remember dy dx is equal to the change in y with change in x. You're actually just saying here that dy is equal to 0. And the reason why I'm going to do that is because of the fact that we've got a fraction with obviously algebraic expressions top and bottom. So what you want to do to solve this is you're actually going to set your numerator equal to 0, isn't it? So I'm going to do that. 108 minus 3x plus y all squared is going to equal 0. And then that way we can use algebra, solve it. Remember, we have this curve as well. This is the actual curve. Use algebra to solve it simultaneously to figure out what x and y must be. Now, as well as that, this has come up before in paper 1, question 9 of June 2018, whereby they asked you for the points furthest east and west, I think it was. So yeah, that's another thing. So if they ask you for the points that were furthest east or west, well, what would happen is that, well, the tangent lines would be vertical, wouldn't it? It would be vertical here, right? And it would be vertical there. And in that case, what you would do is say, well, if your tangent line is vertical, there's no change in x, right? So in that case, your dx would equal 0. And that would just mean you would set your denominator equal to 0. So that's just something to think about. Anyways, back to this question. So we know that we need to set the numerator equal to 0, and we need to figure out the point, how far the point Q is. So looking at the picture, looking at the diagram, the point Q is over there, right? Now, there's a point P and Q. Point P has a y coordinate that's positive. Point Q has a y coordinate that's negative. So when I want to solve this simultaneously, I'm going to choose to get everything in terms of y, because I know for a fact that one of them is going to be negative, one of them is going to be positive, and then I can just figure out which one it is, because it's going to be the negative one. Whereas if I was to do it with x, which is not a problem algebraically, right, you'll still get the same thing. But the x coordinates are both positive, right? So what you would have to do is obviously say, well, Q is furthest away from the origin. So it's going to be the greater x value. You get that greater x value, then you plug it back in to figure out what y is. So it's just an indirect way of getting to y. So that's just another thing to think of. Think about which value you want to choose to solve to make life easier, to make life faster, right? So we're going to use algebra to solve both of these and figure out what y is. So doing that, I'm going to say 108 is going to equal 3 lots of x plus y all squared. Divide that by 3. 108 over 3 is going to equal x plus y all squared. 108 over 3 is something that I should know. 36, yeah, of course. So I've got 36 is equal to x plus y all squared. And then now I'm going to square root. So I'm going to have, I'll flip it. X plus y is going to equal plus or minus 6, isn't it, if I square root it? Now we are here. Remember our original curve is that there. Let me actually grab it, actually. So we have it. So remember, because you've actually got an expression for x plus y in your original curve, you don't actually need to rearrange this one anyway. You can just plug it in. But the question is now, which one am I going to pick? Am I going to pick x plus y is going to be positive 6 or x plus y is going to be negative 6? Well, if you look at the question, if we are solving these simultaneously, right, then we know that each of them is going to give me a pair of coordinates, isn't it? Because it's a quadratic simultaneous equation. So with that being said, if I was to try both of them, one of them is not going to work in the context of this question, just due to the fact that we have 2 pairs, right? If both of them would work, then I would have 4 pairs, but that doesn't make sense because we only have 2 pairs of coordinates that we're looking for P and Q. So which one do you pick? Well, I just pick positive first anyway, right? That's what I would do. So let's pick the positive one. And if this works, then I know that I don't need to look at the x plus y equals minus 6. Yeah. So let's plug that in. So I'm going to say x plus y is going to equal positive 6. So if I put that in there, then I'm going to have 6 cubed plus, and then remember what I said, I want to get all in terms of y. So 10y squared, and then this will equal 108, sorry. And then it would be, x would equal 6 minus y, isn't it? So 6 take y over there. And then tidying that up, 6 cubed is 216. So 216 plus 10y squared is going to equal 108 times 6 is 648. Oh, yeah, of course it is. 648 minus 108y. And then now this is a quadratic equation, isn't it? So let's move everything from right to left. So I'm going to have 10y squared there. And then I'm going to have a plus 108y there. And then I'm going to have 260 minus 648. 216 minus 648. That will equal minus 432. That will equal 0. And then it's a quadratic here. I'm going to divide by 2 because why not? But you could put this directly into calculator, it won't change. That's going to be 54y. And that will be minus 216 is equal to 0. So now plugging that into my quadratic solver. That's going to be down here, isn't it? There, polynomial 2, degree 2, 554. and minus 216, I get y is going to equal 3.106, blah, blah, blah. Or y is going to equal minus 13.906. Blah, blah. Now remember, we expect this because when we look at the diagram P and Q, P has a positive y coordinate, Q has a negative one. So this one here is going to be y is equal to minus 13.09. I think it was, or was it 13.9? 13.90, sorry. 13.906. That's that one there. And then this one is 3 point, what was it again? It was 3.106. 3.106 there, right? So the question asks us find how far the point Q is south of O. So it's just literally that y coordinate there. Now it's going down, that's why it's negative. So the actual distance is going to be, if I take the magnitude, it's going to be 13.906. And this is in kilometers. Now the question asks us to give your answer correct to the nearest 100 meters. So obviously let's put this in meters. So I'm just going to write distance. Distance is going to be, if I times that by 1,000, then that would just be 13,906, blah, blah, blah. To the nearest 100 is going to be 13,900 meters. And that is going to be your answer. And that's it. Finished. Okay, so question 12 says, given that 3x plus 4 over x minus 2 times 2x plus 1 all squared is equal to a over x minus 2 plus b over 2x plus 1 plus c over 2x plus 1 all squared, find the values of the constants a, b, and c for 4 marks. So let's go through it. I've got it summarized here. So remember when you're doing this, you're going to multiply this denominator on both sides to cancel it on the left. So I'm going to have 3x plus 4 on the left, and then this will equal, and if I multiply it with the a, then that a will cancel with that. That x minus 2 will cancel with that, and I'll just be left with a bracket 2x plus 1 all squared. And then for the next one, b, well, I'm going to have the x minus 2, aren't I? And then one of the 2x plus 1s is going to cancel, so I'll just be left with 1 like that. And then for the last one, c, the 2x plus 1 all squares will cancel, and I'll be left with x minus 2. Okay, so now we're here. We need to just eliminate each of these constants here. So what I'm going to do is I'm going to eliminate, I'm going to make this 0, right? If 2x plus 1 is equal to 0, that means that x is equal to minus a half. So I'm going to put x equals minus a half into the formula or into the equation and see what we get. So for this one, that's just going to be, I'll just do it in my calculator so it's super quick. Here we go. So it's going to be 3 times minus a half plus 4. Which is going to be 5 over 2. So that's going to be 5 halves. And then that's going to equal, that is going to go. And so will this one. So I'll be just left with c, isn't it? So it'll be c, and then it will be minus a half minus 2. And that will be 5 over 2 is equal to c. And then that is minus a half minus 4 over 2. That's minus 5 over 2, isn't it? So if I divide both sides by minus 5 over 2, I'm going to get c is equal to minus 1. So c is minus 1. Now I'm going to make this 0, right? X minus 2 equals 0, that means that x is going to equal 2. So I'm going to plug in x equals 2 into there. So if x is equal to 2, then if I plug 2 into there, I'd have 3 times 2, which is 6. 6 plus 4 is 10. So it'll be 10 is equal to, and then on this one, 2 times 2 is 4. Add 1 is 5. That's 5 squared. This is going to be 25a. And then that will go. B and C will both go because they both have x minus 2s. So I'm here. And that means that 10 over 25 is equal to A. And that means that A is equal to, divide top and bottom by 5 is going to be 2 over 5. So A equals 2/5. Now I've got at least 2. To get the last one, you can just set anything equal to, you can set x equal to anything. I always like to do it equal to 0. So x equals 0, if I plug that in, that is going to be, if I plug in 0 into there, that's going to go, it's just going to be 4 on the left. It'll be 4 on the left, and then that will equal, let me zoom out a bit so we can see everything. If I plug in x equals 0 into that, then it's just going to be a, and then 1 squared, like that, and then plus b, and then it's going to be minus 2, 1, plus c, and then minus 2. Now we have A and C, so we can figure out what B is, isn't it? So tidying that up, 4 is equal to 1 squared is 1, that's going to be an A. Or to be fair, A is 2/5, or you know what, I'll do it after. So it's super clear. That's going to be minus 2B. and then that's going to be minus 2c, and then let me plug in a and c now. So 4 is going to equal, a is 2 over 5, minus 2b, and then minus 2 lots of c, which was minus 1 over there. And then that way, that means that 2b, if I move that to the left and I move this to the right, then it's going to be, or let me just tidy up before I do that. 2/5 minus 2b plus 2, and then let me do it now. So I'm going to move 2b to the left, so it's going to be 2b is equal to, and it will be 2/5 plus 2 minus 4. So I'll just put that into my calculator so we can just do that very quickly. 2 over 5 plus 2 take away 4. That is minus 8 over 5. So 2b is equal to minus 8 over 5. If I divide both sides by 2, then the numerator is going to half, isn't it? So it's going to be minus 4/5. So therefore, we've got our values. So a was equal to, what was a equal to again? 2/5. B is equal to minus 4/5. And C is equal to minus 1, wasn't it? Yeah, perfect. And that's part A finished. Okay, so part B says, hence find the exact value of the integral between 7 and 12 of 3x plus 4 over x minus 2 times 2x plus 1 all squared dx. Given your answer in the form P, L, and Q plus R, where P, Q, and R are rational numbers. This is 6 marks. So I've just got what we need from part A to do this question. Now remember, we split something into partial fractions, and the whole point of doing that is that we can actually integrate it from this point. So in this current form, it's not very nice, right? We use partial fraction decomposition to get it into a form that we can integrate. And we can see that they want it in the form of ln, so that's always a key indicator as to how to go about this. So let's actually plug in a, b, and c, right? So we're integrating this, but that means we're gonna integrate that. So we're gonna use this instead. So what I'm gonna do is firstly let me put the values in. So if I write it like this, 2/5 and then x minus 2 plus b, sorry, not b, minus 4/5, because that's what b is, minus 4/5, and then 2x plus 1, and then plus c, which is minus 1 over 2x plus 1 all squared, right? Now, algebraically, I don't like the fact that these fractions are on the numerator. You can actually put this one on top. You can put this 2 on top, and then that division of 5, you can actually put with the denominator. So we can actually write it a bit neater. So it's actually 2 over 5, and then it's going to be x minus 2. You can write like that. And then this minus here, there's a minus there, it's going to be 4, and then over 5, and then 2x plus 1, and then minus 1 over 2x plus 1 all squared. And now we are integrating this between 7 and 12, isn't it? So how do I go about doing that? Well, what I would do is I would integrate it term by term. I mean, you're gonna have to do that anyway, but I'll just literally separate them. So I'll do this. So the first integral is 2 over 5 and then x minus 2 dx. Now, to be honest, I have put it in this form, right, but I can actually go a step further. I can actually take that 2/5 outside the integral, right? Because it's just a constant, and you'll see why in a moment. If I do this like that, I'm going to have 1 over x minus 2 dx, right? Now, whenever you're integrating a fraction, guys, especially in year 13, always have a look at the denominator and see if you differentiate, you get something that looks like the numerator. Now, when I differentiate the denominator here, when you differentiate x minus 2, you get 1, right? That is the numerator. So this is just an ln integral, isn't it? So I'll just show you what I mean. So generally speaking, if I've got the integral of f dash of x over f of x dx, then this is equal to the ln of the modulus of f of x plus c, right? So with that being said, let me put that there. With that being said, that would mean that this integral here is just going to be 2/5, and then we're going to multiply by, well, it's going to be the ln of x minus 2 modulus, right? Always put modulus just in case you run into any negatives, yeah? So that is going to be that. Obviously, it's going to be plus c, but we're not actually doing that by itself. It's a definite integral, so I'll just leave it without the plus c for now. So that is going to be answer to that integral, right? 2/5 ln of x minus 2. And then I'm going to do the next one. The next one has a minus there, so I need to remember that. So I'm just going to integrate 4 over 5. So let me get here. So it's going to be 4 over 5, and then it was 2x plus 1, wasn't it? Perfect. And then the same thing I did before, right? I actually want to be a bit clever with this one. So if for example, if I take out the 4/5, which I can do, right, I'll get 1 over 2x plus 1 dx, which is not a problem. However, because when I differentiate 2x plus 1, I get a 2. If I had a 2 there, that would be very convenient. But I can put a 2 there because there's a 4 here, right? Two 2's are 4. So I could put a 2 there, and that would mean I would get a 2 there as well. And that is the exact same thing. That is the exact same thing, right? Because that 2 can come outside as well to make 4/5. So this is the exact same thing. The reason why I'm leaving the 2 inside is because when I differentiate the denominator, 2x plus 1, I get 2, and that is the exact numerator now. So I can just say straight away that this is going to be 2/5, and it's going to be multiplied by the ln of 2x plus 1. So that one's done. Fantastic. So let me put these in circles actually, in red circles, so I know that I need to grab them after. So I've done the first two terms. I've got one more term to do. Now I've got this one at the end. Again, this is a minus as well, so I won't forget that minus. So I'm going to integrate 1 over 2x plus 1 all squared. So integrate 1 over 2x plus 1 all squared dx. Okay, now, how do I integrate something like this? Well, you can actually rewrite this algebraically, but I'm going to bring this up, and that would mean it's equal to 2x plus 1 all to the minus 2, isn't it? Now, when I look at this here, this looks to me like a chain rule problem, right? So when I look at this, I need to ask myself, okay, well, it's an integral problem I'm doing. Maybe the reverse chain rule. I remember how the reverse chain rule works. You're basically reversing the chain. You want to ask yourself, what would I differentiate to get the thing that I need to integrate, right? So with that being said, what you're going to do is you're going to increase the power. So I've got a minus 2 there. If I add 1 to that power, minus 2 plus 1 is a minus 1, yeah? And I'm going to just say y is equal to that. Now, if I wanted to differentiate this, I would use the chain rule, wouldn't I? dy dx, the minus 1 will drop to the front. It will be 2x plus 1. And then I would take 1 away from the power, minus 2. And then I would times by whatever I get when I differentiate in the inside. 2x plus 1 differentiates to 2. So therefore, it's going to be minus 2, and then it's going to be 2x plus 1 to the minus 2. So with that being said, if the question asks me, for example, I write e.g, if it asks me to integrate minus 2, 2x plus 1 to the minus 2 dx, right? I know that this is just going to be the top, isn't it? Because I've differentiated it. When I integrate, I'm undoing that derivative, aren't I? So it's actually going to be the same as 2x plus 1 to the minus 1 plus c, isn't it? Right? So with that being said, we're not asked to integrate that with a minus 2, right? We just have that. So you need to ask yourself, okay, well, fine. If I write that underneath, like that, dx, what is the difference between this integral and that? It's just a constant, right? If I times by minus a half, right? That will give me that one there, wouldn't it? Yeah? Dividing by minus 2, same as times by minus a half, right? So that would mean that this integral is going to be minus a half, like that, because I'm going to do the same thing, like that. It's going to be 2x plus 1 to the minus 1 plus c. Yeah? So that means that this integral, the one that we're actually looking for, is equal to minus a half times 2x plus 1 to the minus 1. So that means I've now got all of the integrals. So let me make that equal, and then I write it there, and then I'm going to bring everything. So you got to be super careful and tidy with these questions. So let me put this in a red circle as well. And then now, what was the question again? We were integrating this here, and now we've got the integral of each of these. So now we just need to apply the limits, and then we're good to go. So this is the actual question. The first integral, let me write it now. We're writing square brackets, aren't we? Because we've integrated now. It's between 7 and 12. The first answer to the integral was this one here. 2/5 ln x minus 2. So I write that there. So 2/5 and then ln and then modulus of x minus 2. And then we had a minus, right? I didn't include the minus when I was integrating though. So the second one is this one. 2/5 ln 2x plus 1. 2/5 ln 2x plus 1. And then the last one, I didn't include the minus. I just integrated it without the minus. I got this answer here. So when I put that in there, it's going to be another minus a half. And then it's going to be 2x plus 1 to the minus 1. Perfect. And obviously these two minuses now, I can actually make a plus, can't I? So I can write a plus instead. Perfect. Now, we need to evaluate this. What I can do first is log laws. If I were to take out a factor of 2/5 like that, then it would be, just from the first two anyway, it would be I write a bracket, ln of x minus 2 minus the ln of 2x plus 1, like that. And then we can use our log laws to put it in one. I'm just doing it step by step, so it's super, super clear. I'm sure you guys will be able to do it in one go, which is fine. But for the purpose of a walkthrough, I'm going to just be super, super clear like that. And then 7 to 12. And then obviously now log laws, ln a minus ln b is ln a over b. So this just becomes 2/5 and then ln of x minus 2 over 2x plus 1. Like that. And then plus a half and then 2x plus 1 to the minus 1 and then between 7 and 12. And then now I'm in a position to just evaluate, right? So let's go ahead and do the upper limit. So if I plug in the upper limit, it's going to be 2/5 of ln, and then it's going to be 12 take away 2 is 10 over 12 times 2 is 24, right? 24 plus 1 is 25. So that's going to be 25 there. And then plus a half. And then what is that going to be? That's going to be 25 again, isn't it? 12 times 2 is 24 plus 1, 25. That's going to be 25 to the minus 1, which is 1 over 25. That's 1 over 50. Yeah? So let me just put that like that. Then now let me tidy this up first, actually. So it's going to be 2/5 ln, like that. 10 over 25 is the same as divide top and bottom by 5. It's going to be 2 over 5, like that. So yeah, that's fine. Perfect. And then plus, and then this there, you could put in your calculator. This is just going to be 1 over 50. All right. Okay. So now lower limit. Let's do that. 7. Let's plug in 7 and see what we get. You can do this on the calculator, by the way. So yeah, you're fine. Anyways, next one's going to be 2/5 ln of 7 minus 2. 7 minus 2 is 5. 2 times 7 is 14. Plus 1 is 15. Like that. So 5 over 15, which I can simplify to a third. I'll do that later. And then plus 1/2. And then plug it in that. 2 times 7 is 14. Add 1 is 15. That's 15 to the minus 1. Like that. Perfect. Okay. So now tidying up a bit more. 2/5 ln of 5 over 15 is a third. Like that. And then plus, if you put this into a calculator, you're going to get 1 over 30. Because that 15 plus 1 is 1 over 15. You're going to get 1 over 30. Like that. Okay. Perfect. So now, doing this now, let's tidy up and see what we get. So we're going to have 2/5. And now, to be honest, because these arguments are positive, I can get rid of the modulus signs now. So it's going to be ln 2 over 5 plus 1 over 50 minus 2/5. And then ln of a third. And then minus 1 over 30. Now, they wanted it in the form P ln Q plus R, isn't it? So let's combine the ln's together. So if I combine the ln's together, it's going to be, I could take out a 2/5. And it will be ln 2/5 minus ln a third, like that. And then it will be plus 1 over 50 minus 1 over 30. So let me put it into the calculator and see what I get for that, for the fractions. So 1 over 50 minus 1 over 30. That is equal to minus 1 over 75. So that's going to be minus 1 over 75 there. And then I've got 2/5 there. And then log laws now. ln 2 over 5, right? Divided by a third, isn't it? Which is going to be 2 over 5 times by 3 over 1. Like that. And then that would be 2/5 ln. And then that's just going to be 6 over 5. Isn't it? 6 over 5 minus 1 over 75. And that is your answer. So P is going to equal 2/5. Q is going to equal 6/5. And R is going to equal minus 1 over 75, isn't it? Because they wanted, did they put as plus? Yeah, perfect. Perfect. And yeah, that's it. Quite lengthy, but yeah, finished. Okay, so question 13 says, show that the equation 3 sine theta cos theta over cos theta plus sine theta is equal to 2 plus sec 2 theta times cos theta minus sine theta can be written in the form 3 sine 2 theta minus 4 cos 2 theta is equal to 2 for 3 marks. Okay, so I've just got it summarized down here. Now, the first thing I'll say with this question is that I can see it's to show that the equation, right? And this equation obviously has two lines, whereas an identity, which is what you're typically used to seeing in an exam, has three. Now, what are the distinctions? Remember, an equation, right, has specific values of theta which would work. An identity is all values. We're saying that the identity is the same as the left hand side, same as the right. And when you're proving an identity, you're only allowed to use one of the sides. So if I start with the left hand side of an identity, I can only use I have to use algebra to obviously show I get the right hand side. And if I want to use the right hand side, I can only use the right hand side to prove that I get the left. You can't mix and match. You can't move things over the equal sign. You can't times, you can't divide on both sides and so on and so forth. So it's super, super important you guys understand the distinction, right? Now, this one says show that the equation, right? It's not an identity. There aren't three lines, which means that I'm actually allowed to move things over. I can times, I can divide, and so on and so forth. So there's a very, very important distinction there. And I put a couple of questions now in a graphic to show you what I'm talking about. Typically, you're used to prove or show that, right? Left hand side is the right. This one is different. It's to show that the equation. So now that we've cleared that up, we can now say we can move things around, right? Now, let's look at what we're actually trying to show. We're trying to show that we get 3 sine 2 theta and 4 cos 2 theta is equal to 2. Now, the main thing that I see here is that I've got 2 thetas here. This is the double angle formula, right? Which is not given in the formula book, so you need to memorize them. So what do I do from here? Okay, when I look at the thing that I'm actually trying to show, right? There's so many things going on here. Straight away, sine theta cos theta, that looks like 2 sine theta cos theta, the sine 2 theta formulae. I've got a sec 2 theta, which I know is 1 over cos theta, 1 over cos 2 theta. And another thing as well is that I actually have a cos theta plus sine theta and a cos theta minus sine theta here, right? I don't think that's a coincidence. That looks very, very similar, right? What do I do? Well, I'm going to bring these together and you're going to see why. So the first thing I'm going to do is I'm going to multiply both sides by cos theta plus sine theta. And if I do that, it's going to be 3 sine theta cos theta is going to equal 2 plus sec 2 theta. And then it's going to be cos theta minus sine theta, and then cos theta plus sine theta. Now, the reason why I'm doing that is because I can see quite clearly that this is a difference of 2 squares, isn't it, right? If I expand this, this is going to be cos squared theta minus sine squared theta. And this is very, very helpful because firstly, it simplifies it, right? We had 2 brackets there. We've created 1. And another thing as well is that, well, this is an identity. Cos squared minus sine squared is cos 2 theta, right? And we know we want that in our equation. So that is definitely the right way to go. So I'm going to write cos 2 theta here, like that. And then obviously I'm going to just write these two now. So 2 plus 2, sorry, not 2, 2 plus sec 2 theta. And then 2 plus sec 2 theta there. So we're there, and then this is equal to 3 sine theta cos theta. Okay. Now, remember when you're doing these questions, always have what you're trying to show at hand. So we've got a cos 2 theta, which is great. Now, as I was saying before, sine theta cos theta, you should recognize that. Remember your identity. Sine 2 theta is equal to 2 sine theta cos theta. This is an identity right here. But we don't have a 2 at the front. We've got a 3. So you just want to ask yourself, okay, that's not a problem. It's just an adjustment of a constant, isn't it? 2 to 3. What do I times 2 by to take me to 3? That's just going to be 3 over 2, isn't it? Think of it as 2x equals 3, x equals 3 over 2. If I times both sides by 3 over 2, I'll get that side, which would mean that this side is going to be 3 over 2 sine 2 theta, isn't it? And then that means we can replace this with that, right? So now it becomes 3 over 2 sine 2 theta, and that will equal 2 plus sec 2 theta cos 2 theta. Now, let's expand this right-hand side. If I do that and that, right, that will give me a 2 cos 2 theta. And then if I do that and that, remember sec is 1 over cosine. So when I do sec 2 theta, I do it here. This is 1 over cos 2 theta, isn't it? So if I do sec 2 theta times cos 2 theta, then that is literally just the same as doing 1 over cos 2 theta times by cos 2 theta, and they cancel, right? So cancel, you're left with 1. So these two is just going to give me 1, isn't it? Yeah? And then obviously we get this now. We got 3 over 2 sine 2 theta. Now let's look at the show that again. It's to show that we get 3 sine 2 theta minus 4 cos 2 theta is equal to 2, right? And we are right here. So what do? Well, we have a fraction. We don't want a fraction. We can see that we've got a 3, so it's quite clear to see. We're just going to multiply everything by 2, aren't we? So let me just do it here. Multiply everything by 2 times by 2. We're going to get 3 sine 2 theta is equal to, remember, times this by 2 as well, and that by 2. It's going to be 4 cos 2 theta plus 2, and then move this to the left and we're done. So we're going to get 3 sine 2 theta minus 4 cos 2 theta is equal to 2. And that's it. Finished. Okay, so part B says, hence solve for x between pi and 3 pi over 2. 3 sine x cos x over cos x plus sine x is equal to 2 plus sec 2x. Times cos x minus sin x, giving answer to 3 different figures, and this is a 5 marker. Now remember, with these types of questions, there's always in 2 parts. Part A is a show that, and in part B you use your show that to solve the equation, right? The whole point is that you're rewriting an equation with identities, right? With the use of identities to help it to make life easier, right? Now let's go what we did in part A again. Remember, we showed that this equation there was equal to that underneath, right? And the difference between this one and the one in part B is the theta has been replaced with an x. So what we actually want to solve, right, is actually just 3 sine 2x minus 4 cos 2x, isn't it? Is equal to 2. That's what we want to solve, yeah? So I can delete this now. Now, we want to solve that. How do I go about solving that? Well, the first thing that I think of as well, if this was a 0, it's not, but let's say it was a 0, then I could move that to that side, then I'd get 3 sine 2x is equal to 4 cos 2x. And then I could divide the cosines and the 3 to get sine 2x over cos 2x, right, is equal to 4/3. And then obviously sine over cos is tan, isn't it? So we actually eliminate the sine and cosine and get that. And then we could just do the tan inverse and so on and so forth. Now, this is a good way to do it. However, that wasn't a 0, it was a 2, wasn't it, right? So if it was a 0, I could do that. But the fact that it's not a 0, I can't do this. So let me delete all of this and put the 2 back, right? Now, if you look closely, we've got a 3 sine. Let me just change it to a 2 before I forget. Okay. So we've got 3 sine 2x minus 4 cos 2x, right? Sine minus cosine. Where does that come up? Well, if you look at it closely, it's actually an harmonic identity, isn't it? Remember, and I actually got a graphic that I've actually got down here, right? Remember from 7.5 in the textbook for year 2, right? You've got these different type of expressions, and it will allow you to rewrite them in terms of only one trigonometric expression, right? For example, the top one, a sine x plus b cos x, can be expressed in the form of r sine x plus alpha, and obviously the minus is at the bottom here, so the minus will be there, right? So this is a type of question whereby you may have to use these to solve an equation. And it's not just in that typical modeling type of question that you get with harmonic. It can also come up with these types of questions as well. So be aware of it. Now, how does this work with the question that we've got? So let's look at it, right? We're doing this equation here. 3 sine 2x minus 4 cos 2x, right? So if I just get that graphic, it's the top one actually, because it's sine and cosine. So if I get this right here, I'm just going to copy this bullet point here, and then I can delete. Actually, no, let me not. I'll just put this here. So if I put this there, right, if I compare this, well, it's a minus, right? So what this is telling me is that, well, a sine x, right, minus b cos x is equal to, minus is at the bottom, this is a minus there, it's going to equal r sine of x minus alpha, right? If I compare that with what we've got 3 sine 2x minus 4 cos 2x minus 4 cos 2x, and that will equal, well, r sine, right? And then if you just look closely, the x is now a 2x, now it's just 2x minus alpha. So what we can actually do is say that we can actually just rewrite this with that, and we just need to figure out what r and alpha is. And this is good because now we've gotten rid of the cosine, we just have a sine. So we need to figure out what those are. Now remember, I've actually got this summarized here as well. These right here is what I need, yeah? And then now I can actually just let me grab that, and then I can delete this, and then we can get to work. So if I go back up here and then I just copy that, then that will allow me to tell me what r is and a and b. So From there, I can see that r cos alpha, right, is A. Now, what is A in our case? A, we can see quite clearly, is 3. B, quite clearly, is 4. Yeah? So if r cos alpha is A, that means r cos alpha is equal to 3. And that means that r sine alpha is equal to 4. Right? And then from there, we could figure out what alpha is by dividing them. So remember, r sine alpha over r cos alpha is going to equal 4 over 3. And then from here, remember, the r's are going to cancel. Sine over cos is tan. This is tan alpha. Tan alpha is equal to 4/3, like that. And then now that way I can figure out what alpha is. So I'm going to do the tan inverse of 4/3. So tan inverse of 4 divided by 3 is equal to that there. And I'll just do it to 3 significant figures. That should be fine. So alpha is equal to 0.927. And then now obviously to get r, it's quite easy. It's just Pythagoras, isn't it? That's going to be 3 squared plus 4 squared. And that is just root 25, which is 5. So now we've got r and alpha, we can rewrite this expression here. Remember, we were saying that 3 sine 2x minus 4 cos 2x, right? We can now rewrite it with r and alpha. So let me copy this and put this down. And then after I'll put it back and then we're pretty much in business. So this was it. Now we know what r and alpha is. I can replace it. Replace that, replace it. R is 5. So that will go there. And then alpha is 0.927. 0.927. Perfect. And now remember, this was equal to 2, wasn't it, from this one, right? So now we can actually just put that back and then we can just solve it now. So that there, that just means then that 5 sine of 2x minus 0.927 has to equal 2. And now we can just solve this easily now. So dividing by 5 is going to be sine of 2x minus 0.927 is equal to 2 over 5. Now I'm going to do the sine inverse part. Let's get our range again for the actual question. The range was that one. X is between pi and 3 over 2 pi. Now, we've got a lot going on in this angle here. So what I'm going to do is I'm going to adjust the interval just so I can see what values or value I need, right? So if x is between pi and pi over 2, then 2x, right? Times both sides by 2 is going to be 2 pi. That's going to be 3 pi, isn't it? Like that. And then now I'm going to take away that 0.927. So it's going to be 2 pi minus 0.927. It's going to be like that. 0.927 like that, and then 3 pi minus 0.927, just so I can see what the actual value I need is going to be once I do the sine inverse. Okay, so let me actually just work out what those are roughly, right? So 2 pi minus 0.927, that gives me 5.35 blah blah blah. Sorry, 5.35, what was it, 356? Yeah, 6 1 blah blah blah, like that. And then this one is going to be between I'll change that to a 3 pi, and that gives us 8.49 quadruple 7, I think 8.49, and then lots of sevens like that. So what that tells me is that now when I solve this one, I just need the value or values that will be within that range, isn't it? Which is going to be between 5 and 8 essentially. So let's get the equation again. So let me do the sine inverse of this now, and I now know where I need to go, right? So sine inverse of 2 over 5 is going to be 0.411. That's going to be principal value. So I'm going to say then that 2x minus 0.927 is going to equal that one there, 0.41151, blah, blah, blah. And then the next one, remember, this is sine. The next one is going to be 180. I always use 180, but it's radians, so it's pi. Pi minus that principal value. That would go over there. So I'm gonna find out what that is. Before that though, let me do that. So pi minus answer is gonna give me that one there. So the next one's gonna be 2.73. So it's gonna be one of the other ones, isn't it? 2.73 0 blah blah blah. Now we need it between 5 and 8. So let's just figure out what that is. So remember, we've got these two values now. To get this one, To get the next one, I'm going to add on 2 pi. Remember, the period of sine is 2 pi. So to get that one, I'm going to add on 2 pi onto that one. And to get that one, I'm going to add on 2 pi onto that one. So let's see what we get for those. So that one, let me go back to the original value. Or to be fair, because I've got that one stored, let me just do that one first, actually. I'm going to do answer plus 2 pi. I get that one there, yeah, which is going to be 9.0. Let me just check. Yeah, that's fine. That's going to be 9.01 3 blah blah blah. So it's not that one, it's going to be this one, isn't it? So I'm going to do the principal value, which is going to be that one there. Perfect, got it stored. I'm going to do that answer plus 2 pi, and that gives me that number there, 6.69 470. 694,702 blah blah blah. So it's going to be that one, isn't it? Because remember, we wanted it between 5 and 8. Yeah, that's the only one that's between it, so we're choosing that value. So then now what we can say then is that this one, if I put this here, it's going to be, let me zoom out a little bit so you can see everything clearly. Yeah, so now it's literally just going to be 2x minus 0.927 is going to equal 6.694702 blah blah blah. And then that would mean then essentially that x is going to equal, add that on, 6.94702 blah blah blah, add on the 0.927, whoops, 927, and then divide it by 2, and that is going to be our answer. So x is going to be, and I've got that number stored, so let me just put that in. So it's going to be essentially just answer plus 0.927 divided by 2. And that gives us that number there. And it's set to 3 significant figures. That's going to be 3.81. And that's it. That's finished. Okay, so question 14 says, figure 3 shows a container in the shape of an inverted right circular cone which contains some water. The cone has an internal radius of 3 meters and a vertical height of 5 meters as shown in figure 3. At time t seconds, the height of water is h meters, the volume of the water is v meters cubed, and water is leaking from a hole in the bottom of the container at a constant rate of 0.02 meters cubed per second. The volume of a cone of radius r and height h is a third pi r squared h. Part A says show that while the water is leaking, h squared, the h dt, is equal to minus 1 over k pi, where k is a constant to be found. And this is a 5 marker. So there's a lot going on here, right? And I don't like to call them. They are called forming rates of change, right? Now, what you want to do with these types of questions, because it hasn't come for a couple of years, is first you look at what they want you to show, right? They want you to show something with the HDT. That is a rate of change. Now, what you want to do here is apply the chain rule. Now, remember from the beginning of year 13 or whenever you're taught it, right? The chain rule states that dy over dx, right, is equal to dy over du, we use the u, times by du over dx, right? There's a connecting variable u here, which connects these rates of changes together, right? Think of it as a fraction, the du's cancel, right? Goodbye, goodbye, you're left with dy over dx, isn't it? So the fact that I want dh dt tells me that I'm going to use that. So I'm going to say dh by dt, right, is going to equal dh with some unknown thing times that same thing that I don't know quite yet, dt, right? Because the question marks will cancel and I'll be left with dh dt. So the question is what is that connecting variable that connects h and t together, right? Now just have a look at the question. It's very easy to spot, right? Now let's read it again. At time t seconds, the height of water is h meters. The volume of water is v. What other variable is in this question? You have h, you have t. Volume hasn't been used. It's going to be v, right? So I'm going to change these to dv's. Yeah, it's the most logical thing to do. Okay, so this is my equation. Yeah. Now, as well as that, what do we have here? Well, I've got dhdv. That means I need a formula which connects h and v together, and I also need a formula that connects the volume and time together, right? Or maybe not a formula, but we'll see. So let's read it. Let's continue. It says, and water is leaking from a hole in the bottom of a container at a constant rate of 0.2 meters cubed per second. This is a rate of change. This is the rate of change of the volume with respect to time, isn't it? Look at the units of measurement. Let me write it like this actually, 0.02, right? And then meters cubed, and then I'll write s to the minus 1, I can write it like that, can't I? That meters cubed, if I just think of it as units, that's a volume, right? That is a time. This is a rate of change. So I wrote D. It's time here, right? This is a rate of change. This is dV over dt, isn't it? And also it's leaking, by the way. So do not forget the negative sign. It's going to be minus. So from there, what I can actually deduce, let me just move this out of the way so it's super clear, like that. So what I can actually deduce is from that piece of information, dV by dt must equal minus 0.02. Yeah. And that further confirms that V was our connecting variable, because now I can just replace that. That is just minus 0.02, isn't it? So now what I've done actually, because we've got that, let me just grab this. And then I've screenshot a couple of things down here that we need. Perfect. Okay. So remember what we're trying to show? We've now figured out that the VDT, right, is minus 0.02. So what I'm going to do is I'm going to put that in. So I'm going to say dH by dt is going to equal dH by dV multiplied by minus 0.02, the rate of change of the volume with time. Now, what's left to figure out is dH by dV. I need a formula that connects the height and the volume together, right? Now, remember at the beginning, they actually gave us the formula for the volume of this cone, didn't they, right? The volume of a cone with radius r and height h is a third pi r squared h, isn't it? So I'm going to write that there. So I'm going to write V. Let me just zoom out a bit. Okay, perfect. Okay, so I'm going to write V is equal to a third pi r squared h. Now this is good because I can see a v and I can see a h. However, there's a slight issue here. I've got that variable r. I don't want an r because I need v and h, right? Because I need dh by dv. So for me, I need to get rid of that r. Now, how do I do that? Now, you're dealing with cones here, right? With these types of questions, even from GCSE, if you have a smaller cone within a larger cone, they're always going to be mathematically similar. And you're going to use that to figure out a formula which connects R and H together, right? So what I'm going to do now is I'm actually going to screenshot this just to show you what I mean. So let me grab this smaller cone here. Remember, this is actually the height of the water, isn't it, at any point in time? So I'm going to grab this here, right? And then what I'm going to do is I'm actually going to paste this and I'm going to just make it bigger. And I'm just going to just say that this is going to be the actual cone itself, right? And we know the dimensions of the cone. It was radius 3 and height h, yeah? So I'm going to put this here. So I'm going to put radius is 3 and the height is h, isn't it, right? This is of the actual cone. And we're at cone here. And this is the water, isn't it? Right? Which is leaking. And this is going to have a radius of r that we don't know and the height of h. Oh, sorry. That is a 5, isn't it? We know that one. That's a 5. And then this is going to be h. Perfect. Okay. So now we're here, right? Remember, these are mathematically similar, meaning that the scale factors of the lengths are going to be the same. So how do I get the scale factor? Well, it's going to be the bigger divided by the smaller. So if I just do it with the radii, it's going to be 3 divided by r, right? And if I do it for the heights, which have to be the same, it's going to be 5 over h. And this is quite helpful because remember, if we look at our show that, right, we want dh by dv. So we need a formula for v and h, right? So we're going to eliminate r by expressing it in terms of h. And we do this by this equation here, isn't it? Yeah. So what I'm going to do is I'm going to flip these over. It's going to be r over 3 is going to equal h over 5. And if I times by 3, that tells me that r is going to equal 3h over 5, or 3/5 h, whatever you want to use. So now I've got an expression for r in terms of h. I can now plug this into the formula for v, right? I remember we want v to be all in terms of h, so we could figure out a formula for v and h, right? So if I put this here, I'm going to grab this now. Let me grab this and put this here. Like that. Then I can just sub that in, can't I? So if I sub that in, that will be v is equal to a third pi, and then just move that a bit neater, pi, and then it's going to be 3h over 5 all squared times h. And now this is good because remember, now we can just expand it and tidy up. So I'm going to have v is going to equal a third pi, and then times by, that's going to be, if I square the numerator, that's going to be 9h squared. If I square the denominator, it's going to be 25, and we're times it by h. And then tidying that up now, that's going to be, I've got a third times 9, that's going to be 3. So I'm going to have 3 over 25 pi, and then h cubed, aren't I? And then now I've got a formula for v in terms of h. Now remember what the question is asking us for. Remember, we want to figure out what the h dv is, right? So now I know what v is in terms of h. I can differentiate it, right? I can differentiate v with respect to h, and that will give me dv dh, and then I just flip it over. So differentiating that is going to be dv by dh. That's going to equal, the 3 will drop to the front. So 3 times 3 over 25 is going to be 9 over 25. Pi h, and then 3, the 3 drops to a 2, doesn't it? So I get that there. Now, this is dv by dh. What I'm going to do, I'm going to write this as a one singular fraction because I'm going to flip it. So that is the same. If I put it over 1, like that, I can do that. That's just going to be 9 pi h squared all over 25, right? These are the same thing, dv by dh. And now, let me wrap this out actually, just so it's clear. So these two are the exact same thing. I've just written it in a nicer form. So now if I want dh by dv, I just take the reciprocal, I just flip it over. So it's going to be 25 over 9 pi h squared. Now we're in a position to answer the question. Let's go back to the actual question. Question says, show that h squared dh dt is equal to what? Minus 1 over k pi, right? Now, we have this here, the h dt. We now have figured out what the h dv is. We can plug that in. So plugging that into there would mean that I'm going to get dh by dt is equal to, that's going to be 25 over 9 pi h squared, and we're going to times this by minus 0.02. Now, I'm going to plug this in and see what I get, and then I'm going to get to show that again. So what I'm going to do, though, is obviously the show, let me get it now, actually. The show that was that there, wasn't it, right? So we want h squared times the h by dt. So all we're going to do is times by the h squared, actually, in a second. So let's do that. Or you know what, should we do it now? This is what we're trying to get. Yeah, we might as well. Let's get the form that they want it in first, in the sense where they want a h squared on the left. So if I times both sides by h squared, times by h squared, times by h squared, I'm going to get h squared dh by dt, which is what we want. And then that will equal 25 over 9 pi times by minus 0.02. Now, the form that they want it is, they still want the pi, don't they? So what I'm going to put into my calculator now is just this, 25 over 9 times by minus 0.02. So putting that into my calculator will give me, let's see, 25 over 9 times by minus 0.02. That gives us minus 1 over 18, right? So therefore, we're going to have h squared dh by dt is going to equal minus 1 over 18, right? Times that 1 over pi, like that. And then that is just going to be minus 1 over 18 pi. So we've done it. dh by dt. Perfect. And obviously k is going to be 18, isn't it? And that's it. Very hard question. I haven't seen questions like this come up in a bit. I haven't actually seen a cone question that's come up at all, actually. But I did do a question like this in a couple of walkthroughs, I think maybe 2 years ago. So yeah, this could come up, right? It's a very tricky question. As long as you just remember that cones are similar, then you're good to go. But yeah, that's it. That's question 14a. Finished. Okay, so part B says, given that the container is initially full of water, express H in terms of T for 3 marks. Now, remember what we did in part A? I'll just get it here. We showed that H squared dHdt is equal to minus 1 over 18 pi, isn't it? We figured out what K was. So this is our differential equation, isn't it? So I'm going to grab this here. Now, we need to express H in terms of T. Now, if we've got this and we need to figure out what H is, then that means we need to solve a differential equation. We do that by separating variables. Now, remember, when you solve it, you get a general solution. And then with initial conditions, you get a particular solution. Now, there isn't anything explicit here, but it does say, given that the container is initially full of water. So initially means at the start, that's T is equal to 0. And then from the context, if you're full of water in this cone anyway, right? The cone was 5 meters high, wasn't it? As we saw right here. So what we can deduce from that sentence is that it's just essentially a fancy way of saying T equals 0 and H is equal to 5. So we're going to use this to solve our differential equation. Now, firstly, let's separate the variables. I'm going to times by dt, aren't I? So I'm going to have H squared dH is going to equal minus 1 over 18 pi and then dt, isn't it? And then now I can put the integral signs and then just integrate both sides. So doing that, integrating the left-hand side is going to be a third h cubed, and this will equal minus 1 over 18 pi. And then this is a constant. I'm integrating with respect to the variable t, so I'm going to put a t there, like that. And then plus our constant of integration. Now, how do we find c, initial conditions, which is t equals 0, h is equal to 5, right? So I'm going to plug that in. So I write this here. T equals 0, h is equal to 5 in there. That will give me a third and then 5 cubed. And that will equal minus 1 over 18 pi times by 0 plus c. And then that way, 5 cubed is 125. This is 125 thirds. And then this is going to equal c, isn't it? So that way we know what c is. C is 125 over 3. And now we can update our formula, right? We're going to say that a third h cubed is equal to minus 1 over 18 pi t plus our constant of integration, which is 125 over 3. Now, the question did ask us, though, to find h, express h in terms of t. So we need to get h by itself. So what we're going to do is we're just going to rearrange, aren't we? So doing that, let me just zoom out a bit and let me bring this down a bit more. Okay. So doing that, we need h by itself times everything by 3. I think that's the best way to go. H cubed is going to give me 3 over 18 is a 6. So it's going to be minus a 6th pi t plus 125. And then now, you know what I'm going to do just before I cube root? Let me write this a bit nicer. So I'm going to put that t on the top there. So it's going to be minus t over 6 pi plus 125. And then that means that h is going to be the cube root of all of that, isn't it? So minus t over 6 pi plus 125. Or, to be honest, I like to put the positive term first. It just looks a bit cleaner, doesn't it? So I put it there. 125 minus t over 6 pi. And that will be it. That is h in terms of t. So that's part B. Part C says, find the time taken for the container to empty. Give your answer to the nearest minute. Okay, well, we're looking for a time, right? So I'm going to write find t, right? Now, the formula is in terms of h and t. So we need to find t, right? And well, to find t, we will need a value of h. It says for the container to empty, right? If the container is empty, remember the diagram was like this. If the container is empty, then the height is 0, isn't it? It's all the way at the bottom. There's no more water, yeah? So we're going to just find t when h is 0. So I'll plug this in here. I'll write this here. Find t. Let me write when h is 0, actually. Well, find t when h is equal to 0. So we need to solve that. So we can set this equal to 0 and then cube, but it's actually just the same as making this 0, isn't it? If h is 0, then this would have to be 0 inside. So I can actually just go straight away and just set this equal to 0. But it's the same thing as making this equal to 0, cubing it as well. So it doesn't actually matter, but I'll just go directly to it. So I'm going to say 125 minus t over 6 pi must equal 0. So that way, I'm going to say then 125 is equal to t over 6 pi. And then now that means that the time is just going to be 6 pi times by 125, like that. So I'm going to do that there. 6 times 125 times pi is 750. Yep. So therefore, t is equal to 750 pi. Now the question asked us to go it to the nearest minute. And I believe it was in seconds, wasn't it? Let's just go up to the top. Let's just remind ourselves what the unit of measurement was. T is in seconds, right there, at time t seconds. So let's go back now, and then we're just going to divide by 60, aren't we? So let me write this here. This is in seconds. Whoops. This is in, sorry, this is in, yeah, this is in seconds. Yeah, this is in seconds. We did it in minutes. This is in seconds, huh? So to get to minutes, remember, we just divide by 60. Yeah. So t is going to be 750 pi over 60 in minutes. So I'll put this into the calculator and see what I get. So I'll just do that divided by 60. Won't I? Answer over 60 is going to give us 25 over 2 pi, which is approximately 39.2 minutes. Let me put this like that there. 39.2 minutes. They wanted it to the nearest minute, didn't they? So I'm going to say 39 minutes. And that is our final answer. And that's it. That's question 14 finished. Okay, so question 15 says, figure 3 shows a sketch of the curve with parametric equations. X is equal to 4 sine t, y is equal to 3 sine 2t, where t is between 0 and pi over 2. The region R, shown shaded in figure 3, is bounded by the curve, the x-axis, and the line with the equation x equals 2. Find the exact area of R, and this is 7 marks. Okay, so this one, parametric integration. What do we do first? Well, what area are we looking for? Just in terms of x and y anyway, we're just going to be integrating between 0 and 2. And we're going to integrate the function y, right, with respect to x. This is if it's in terms of x and y in Cartesian form. Now, when you're dealing with parametric integration, it's just a formula you need to remember, and it just comes from this essentially. You're going to integrate y, and you're going to multiply by dx dt, and it's going to be with respect to t. And if you just think of it as a fraction, that will cancel with that, and you're left with y dx. So that's literally all you need to remember. You have y, you multiply it by dx dt, and then obviously just adjust the limits as well, because it's going to be all in terms of t. Yeah. So what I've done actually is I've actually got the question summarized here, or the things that we need anyway. So we are integrating between 0 and 2. Yeah. Now remember the formula is y dx dt times by dt. So what I need to do is find y, find the dt, multiply them, and also adjust the limits as well. So let me put the actual expressions in. So it's going to be y, which is going to be 3 sine 2t. And we're going to multiply by the dt. Now, let me put this here. So if x is 4 sine t, that means the x dt is just going to be 4 cos t, isn't it? Just by differentiating it. So that will go there. T and then dt. And then remember, it's between 0 and 2, but at the moment, this is in terms of x, isn't it? So I need to change these limits. Now, how do I change them? It's in terms of x. Well, I know what x is. X is 4 sine t. So let's change those. And remember, we've got our restrictions on t. So firstly, if we have 4 sine t, right, is equal to 0. Let me write x is equal to 0 here so it's clear to see what I'm doing. X equals 0. That means 4 sine t is equal to 0. I need to solve this. Well, divide by 4, you're going to get 0. When is sine t 0? Well, it's equal to 0, isn't it? Right? T is going to equal 0. You can just take the sine inverse, right? So that's going to be our answer, and it's between 0 and pi over 2. So that one is fine. So that's done. Then now we're going to do x is equal to 2, right? And then we're going to say 4 sine t is equal to 2. That means that sine t is equal to 2 over 4, which is a half, isn't it? So let me write a half instead. And I know that that's 30 degrees in radians. So if pi over 2 is 90, divide that by 3 is going to be pi over 6. So t is going to equal pi over 6. Again, just use your calculator. And this is within the range of 0 and pi over 2. Yeah. So these are going to be our limits of integration in terms of t. So I can now replace these. So let me put this here, copy this, and then I'll put this here. And then now I'm going to change the limits. So it's going to be t equals pi over 6 at the top, because that was for x equals 2, and then t is equal to 0. So I need to solve this now. I need to integrate this now. What do I do here? Well, firstly, I don't like the fact that I've got two different angles here, right? It just makes things just not really nice to work with. So what can I do? I can use the double angle formula to write this in terms of t, isn't it? Remember, sine 2t is equal to 2 sine t cos t, isn't it? Right? So if I've got a 3 there, then I'm just going to times both sides by 3. So that means it's going to be 6 sine t cos t, like that. So I'm going to put that in place instead. So it's going to become pi over 6, 0, and then it's going to be 6 sine t cos t multiplied by 4 cos t dt. Okay, so what I'm going to do now is I'm going to just tidy it up a bit more. 6 times 4 is 24. I've got a sine t, like that, and then I've got cos squared t, don't I? Like that. Okay, so I need to integrate this. Now, how do I go about integrating this? Well, if you look at these types of questions, right, this is actually a reverse chain rule problem, and the way you can spot it is by looking at what you have. Now, if I look at this, sine and cosine, right, forget about the squared for now. These are derivatives of one or the other, right? Sine differentiates to cosine, cosine differentiates to minus sine. So the main thing is that the two expressions we have are related by derivatives, right? Now, what you want to do is actually a little section in the book. I'll put it here so you guys can see it. But yeah, essentially, what you want to do is ask yourself what would I need to differentiate for us to be able to get this sort of expression here? And again, this is where the reverse chain rule comes in. So what do we have here? Well, we've got a sine and we've got a cosine. And what you want to remember is whatever expression has the power, you're going to increase it by 1. Yeah. So if I put this here, I'm going to say, let's try y equaling cosine with a cube instead of a square, right? And instead of writing it like this, I'm going to write it in a bracket and you'll see why, to power 3. Now, if I differentiate that, dy over dt, well, the 3 will drop to the front. It'll be cos t, and then it will be to the power of 2. And then we will times that by the derivative of this here, right? The derivative of cosine is minus sine. So I get that there, right? This is just a chain rule I'm doing. And so therefore this becomes minus 3 sine t cos squared t, doesn't it? Yeah. And now this is the derivative of that there. So if I was to integrate minus 3 sine t cos squared t dt, then I know that that's just going to equal cos cubed t, right? Obviously plus c, but I'm going to leave the plus c for now. Okay. Now we don't want to integrate that. We want to integrate this with a 24 in front. So you want to just compare both of these integrals and ask yourself, well, what is the difference, right? How do I go from that to that? It's just a constant, right? How do I go from there to there? Well, firstly, it's become positive. So I need to times by a -1, right? How many 3's go into 24? 8. So to go from this integral, we times by -8 to get to the one we need, which would mean, because it's an equation, I have to times this by -8 as well. So therefore, the integral is going to be -8 cos cubed t. And that is how the reverse chain rule works. So what I can now say is that this here is actually just -8 cos cubed t, and it's going to be between 0 and pi over 6. And then now we're pretty much done, aren't we? Because all this is now is just evaluating that and seeing what we get. So let me just put this here. Okay. So now, putting that in, we're going to do -8 cosine of pi over 6, like that. And then take away the lower limit, which is going to be -8 cosine cubed of 0, like that. And then see what we get. So, doing that, putting this into the calculator, first one's going to be -8. Now, that's cos cubed, isn't it? So let me put a bracket around it like this. I'll put cos of pi over 6. That's the first one. Calculate is in radians, which is good. Pi over 6. And then it's going to be like that. And then with a cubed, isn't it? So the cube is only the cosine. The cosine's only being cubed. So I'm going to get that there. So that's going to be minus 3 root 3. And then minus, and then that one, that is just -8, I believe. But let's just put in, change that to a 0. Yeah, we get -8. So we've got -8 there. So that's -3 root 3. Two negatives make a positive. And then we can just write this nicely. 8 minus 3 root 3. And that's it. And that's question 15 finished. And that's the paper finished. Hey guys, hope you guys are doing well. So yeah, that's paper 2. I hope you found it helpful. So 15 questions. Any questions that you found a bit tricky, I'm hoping that this walkthrough has clarified it for you. I hope you're in a better position come June now. But I think doing this paper, doing paper 1, and obviously doing all of the other papers that are out there, with on top of your revision as well, I think you guys will be in a good position, and I'm sure you guys will do well. Couple of things. I have a plan of doing 2 more predicted papers. So my plan, wish me luck by the way, because I don't know how I'm gonna pull this off. If I pull this off, then I'm a go. But I'm gonna do another predicted paper 2, and this is gonna be after paper 1. So obviously, once paper 1 is out, we've seen what's inside. I'm gonna make another paper and obviously film it within the time before paper 2 actually comes out. So that'll be at the beginning of June, hopefully. And then obviously I've got a predicted paper 3 for stats and mechanics as well, don't I? So that will come out. I was gonna do that before paper 3, but I mean I'm not gonna do it after. Sorry. I had a plan to do it before paper 1 and paper 2 come out, but I think I'm gonna just do it after paper 2. So yeah, I don't think I have time to do it before and then do another one after that. So yeah, 2 more predicted papers coming from me. I also will be doing, I think anyway, let me just paraphrase. Let me rephrase that. I may do some extra classes. I did an Easter class which went really well, and yeah, I did in that session. There were two lessons, one in the morning, one in the afternoon. I created a document, and yeah, anyone that joined, they're able to access the recordings of it as well, so they can watch it back anytime. So I may do that again, but if I don't, then obviously you guys can have that Easter class as well. But yeah, that's pretty much it. Again, I hope you found it helpful. If you did find it helpful, it's always appreciated if you like, comment, subscribe, share this with any of your friends, anyone that you think would benefit from these videos. But yeah, again, that's it. Wishing you the best of luck with June. I'm sure you guys are going to do well, and see you guys soon. Take care. Bye bye.